Now the topic is array ADT, that is array as abstract data type. Abstract data type means representation of data and the set of operations on the data. Now array is a basic data structure provided by almost every programming language, like C++ provides a array as a basic data structure. So representation of data is defined by the compiler itself. Now the operations on the data is not given by the compiler. We are supposed to implement the operations or provide the operations on array data structure. So data structure array and the set of operations together, we can call it as ADT. So basically we will be learning how we can perform various operations on an array. So here is the list of operations that are possible on an array, and many more operations are possible. So some of the operations here we will discuss in this video, and more operations I'll show you in the coming lectures. Now I will quickly read out just the set of operations here: displaying an array, adding or appending an element in an array, or inserting an element at a given index in an array, deleting an element from a given index, searching for an element in an array, then getting an element from a given index, knowing what is the element present at a given index, and set, that is replacing an element at a particular index, then finding maximum or minimum, reversing an array, and also shifting and rotation of an array. So we'll discuss all these operations and see how these operations are performed on an array, and also we'll analyze them. Now first of all, let us look at the representation of data of an array. So the first thing is we need an array space of some size. So let us take an array of some size, that is array of size 10. Here is an array of size 10. Now the question is, how will you create this array? There are two methods of creating this array, that is statically inside the stack, or we can create it in a heap. So one method is, I can declare a normal array, let us say array of size 10. Now this will be creating an array of size 10. Whenever I run my program, the size of the array will be 10 only. No, I want to create an array of desired size. So for that, you can take a pointer and later you can create an array of required size. I'm writing a C++ syntax here, so it's easy. Instead of writing malloc function, I'm writing just new. So new of size, whatever the size you want to mention. So we can have the size of an array. Let us say size of an array is 10. So a 10 size array will be created. So we have two options for creating an array. If you are following this one, then you must mention the size. If you're following this one, then at runtime you can take the size and create an array from heap. So this option is better for creating an array of required size. So let us assume that we have taken a pointer and created an array. So here A is a pointer pointing to this array. So two things I have completed, array and size. So if you know the size, then you can create an array of required size at runtime from heap. So this is an array creation. So I have written the piece of code for creating an array. Now the next is length of an array. See, I have an array of size 10. It's not necessary that I am using all 10 spaces. I may be having few elements in that one, or I may be using all spaces. So possibility is there that I may or may not be using all spaces. So I want to know presently how many elements are there in an array. So for that, we should also have one more property of an array, that is length. Right now nothing is there in an array, so let us say the length is 0. So I have completed data representation. So I have an array and two more properties, that is length and the size of an array. Now let us perform these operations on this array. Yeah, this section is about array and the operations upon an array. So I will create a new project for array, and all the operations that we are going to learn, I will write them inside the same project, that is inside the same program. At the end of the section, we will have a single program containing all the operations on arrays. So I will start a new project with the name array. create a project. And here is the main function. First of all, I will define a structure for array. In this, we need three members, that is an array itself for storing the number. So I will take a integer type pointer. So this will be an integer array. And the second thing is size. And the second thing is size. And then the number of elements inside the array, let us call it as length. So these are the three members of a array structure. Now here inside the main function, I will create a variable of type array and also initialize it. So first of all, array ARR is the array name. Then for creating an array, I should know what is the size of an array. So let us take it as input from keyboard. So I will give a message here, enter size of an array. Then read input from the keyboard using scanf. I should read the value in ARR, that is inside this array, the member size. I should read size ARR dot size, and this should be prefixed with ampersand. Yeah, with this we'll be knowing the size of an array. Then, once we know the size, we should create an array for this pointer. This is just an integer type pointer. It can point on an array. So we create an array inside heap, then we will make this a point on that one. Here we are able to create an array of our required size. So I have taken the size. Now I will create an array of same size and I will make a point on that one. So say a assign integer type pointer, then malloc function multiplied by size of integer. This a is inside ARR. Now because the malloc function is present in stdlib.h, so I should include that header file. So here I have included header file. Now the following things are initialized. I know the size of an array and I have created an array inside heap and making pointer a point on that one. Then I should set the length to 0 because there are no elements right now. So this is what we need in initialization. So this array will be created in heap. So this type of array structure is more preferable because the size is dynamic. Whatever the required size is, you can take the size. If you want to fill the elements, then you can take the elements from the keyboard or anywhere else. You can bring the elements and fill them in this array. Let us fill few elements in an array and then I will write a function for displaying an array. So for taking numbers, I should know how many numbers are going to be inserted so that I can take them from keyboard. So I am taking variable n. And also for for loop, I need a variable I. Here I'll give a message, enter how many numbers. Enter number of numbers. Then using scanf, I will take the number of numbers in variable n. Now using for loop, I will take all the values from the keyboard and I will store them in an array. I assign 0, I less than n, and then I plus plus. Then scanf, read the elements in an array. So for that, I have to say arr dot a of I, and I should give its address. So here it should be ampersand. Now before for loop, it's better if I give a message that enter all elements. Yes. This for loop will read all the elements from keyboard and store them in an array from starting location to n. After inserting all the elements, I should set length of an array as n because I am inserting n elements. Now here I will write down function for display all the elements of an array. It should take a structure array. Let us call parameter name also ARR. Then it should simply display all the elements. So for that it needs a variable I for using for loop. So it can give a message elements are, then slash n, new line. Then using for loop, I will display all the elements here. I assign 0, I is less than ARR dot length, whatever the length is. Then I plus plus. Then printf percentile d with a space ARR dot A of I. And here inside main function, I will call display function by passing ARR. Let us run the program and test it. Here, enter the size of an array. I will say 10. Number of numbers, I want only 5 numbers. Enter all the elements. So 2, 3, 4, 5, 6. And this display is displaying all the elements here. 2, 3, 4, 5, 6. Here I have inserted all the elements. Then here display is displaying all the elements. Let us debug the program and see how these elements are stored in an array. I'll put a breakpoint here where I am inserting the elements in an array, that is filling the elements in an array, and I will run the program. Enter the size of an array. Size of an array is 10. Enter the number of numbers, 5. Now it has entered in debugging mode. If you look into this debug area, if I expand this array, it is just showing array object. If I expand this array, it is having array pointer that is pointing on some valid address, and the size is 10 and length is initialized to 0. So these are the things already I have finished till here. Right? Then if I expand this A, I cannot find anything. A is a pointer, it is pointing on the first element, and that element is 0. If I fill the elements, let us see what happens. I will continue. Enter all the elements. First element is 7. Yeah, you can see 7 here inside this debug area, that is inside watch. 7 is there. I'll continue. Next element, 8. I cannot see 8 anywhere. See, A is a pointer, it's pointing on an array in a heap, so it is pointing on the first element and it's showing just first element. 8 is just beside 7, so I am unable to see it. As the array is in heap, it will not show all the contents of an array, it is showing a location where pointer A is pointing. So I can continue and fill up all the rest of the elements and also display them. So here inside the debug area, we are unable to see an entire array. Okay, I will stop the program. Remove breakpoint. Now I have another option for discussing the topics. So instead of taking an array pointer, I will change it to an array of size 20. Instead of taking a pointer and creating an array in heap, I am taking a fixed size array. So I will be using this example that is easy for me for explanation purpose. So I will modify the things here. See, I don't have to create an array in heap now, and even I don't have to set all these things. I will remove this part. Now when I am creating an array, at that time only I will directly initialize it inside the object. See, the first thing is the elements. So initially I will fill the elements, that is 2, 3, 4, 5 and 6. I have filled the elements. The next is size. The size is 20. We have given the size as 20. And the number of elements are 5. See, this structure will be initialized with the values that I have given. So the first part is stored in an array, and the second 20 is the size of an array, because I have already mentioned the size here 20, and then 5 is the length of an array, means the number of elements in an array. So directly I have taken a fixed size array, so directly I have filled the values in the declaration and initialization part. So here even I don't have to take all the elements, I will not take all the elements, directly I will call display function. Now I don't need these variables. See, the program code looks very simple so that it's easy for you to understand. I have an array already initialized, then I am calling display function. So let us go to display function. Display function is displaying all these elements. Yes, perfect. So I don't have to modify display function. Let us run and see what happens. Yes, it is displaying all the elements, that is 2, 3, 4, 5, 6. It's perfect. And if I debug this, will it be showing all these elements that are from 2 to 6? Let us check. I'll put a breakpoint on display and I will run the program. Yeah, here inside this debug area, you can see that ARR is an object of type array or a variable of type array. Size is 20, length is 5, and array A is of size 20, so it is showing all 20 elements. All the elements are 0, only first 5 elements are initialized. So I'll be using this example for explanation purpose. That's all in this video. In the next video, you can find the function for insert, and the program will be a same program. So inside the same program, I will be writing a function for inserting an element in an array. First of all, I will fill few elements in this array. So total I have 6 elements. So let the length of this array be 6. Now assume that already I have filled some elements in an array. Now based on this, let us look at these operations. So the first operation is to display. Let us see how we can display all the elements of an array. So first operation, display. Displaying or traversing an array is visiting all the elements of an array one by one. Now here I will show you the procedure by writing some pseudo code. Means not a complete function or a program. Afterwards we will see a complete program combining all these functions together. So let us see the logical part, how to perform the operation. So for that I'll be writing the code. Now for displaying the element, suppose I want to display only the first element, then I should say printf %d a of 0. This will be printing just a first element, that is at index 0. But if I want to print all these elements, then here I should use index. So for that I can traverse through this array from index 0 to 5 by taking a for loop. So for I assign value 0. So initially I starts from 0. So here I can use I. Then I should go till where? Till 5. So that 5 is the number of elements. So 0 to 5 I have total 6 elements. So I should say I is less than length and then I plus plus. So here L is capital. Now this piece of code will print all the elements. First time I value will be 0, so it will print a of 0. The next I becomes plus plus, I becomes 1, so it will print a of 1, then a of 2, a of 3, so on up to a of 5. Now here, instead of using a specific C language syntax, I prefer saying print a of I. So this becomes a pseudocode. Now this doesn't belong to any particular language. It may be C language or C++ or any language. So in C language it becomes printf, and in C++ it may be cout. So this is the method for printing. Now let us go to the next operation, add. So I'll explain that operation, then I will show how it works. Now second operation is add or append. Adding or appending is nothing but adding a new element at the end of an array, that is at the next free space in an array. So we have an array of size 10, but we have only 6 elements. So we have next free space at index 6. So who says that 6 is a free space? Because the length is 6. So 6 means number of elements. So I have 1, 2, 3, 4, 5, 6 elements. Last index is 5, but it is keeping the count of number of elements. So index 6 is a free. So it's very simple. Just in an array of length, I can store an element, whichever element is passed here. So I can store x. So suppose I wanted to insert a new element, that is a 10. So 10 is inserted here. Then now I have total 7 elements. So this length should also become 7. So let us change that length to 7. So I must also update length after performing this operation. So length plus plus. So this will increase the length. So adding an element or appending an element means adding an element at the end of an array. So it's a simple syntax, just 2 statements. So what is the time taken by this operation? The time taken by this operation is, if I say each statement takes 1 unit of time for execution, so just 2 statements are there, so the time is constant. We say time is constant. Now here I will tell you what is the meaning of this constant. So let me go a little bit detailed here. See, the time that I got is 2, so function of time is 2. Now when the function is 2, then what is the degree of a function? So degree of a function is nothing but 2 into n power 0. So what is the degree? 0. So n power 0. So it is order of n power 0. So anything power 0 is written as 1. So that's why we write 1. So actually we mean n power 0. Instead of 1, we mean n power 0. So it's a constant. So the time taken, whenever you get any constant value, you got 2. So it's constant. If you get a 2000 also, it's constant. So whatever the figure may be, when it is a constant, so it's n power 0 and that value is 1. So we are not saying that this 2 is equal to 1, but we are saying that degree of a function is n power 0, that is 1. So this was the simplest operation. So we have finished how to display the elements and we have finished how to append. Now let us see insert. Next operation, insert. Insert operation takes index and the element. So this means inserting an element at a given index. So as an example, I have taken index as a 4 and the element that I want to insert is 15. So it means I want to insert a new element that is 15 at this place. But already some element is there. So I should provide a free space for that 15. So for providing free space, these elements should be shifted forward. Then a free space will open up here, then I can store 15. So for that, I should move 10, then I should move 9, then also I should move 6. Then a free space will appear here, then I can insert 15 there. So 10 should be moved here, 9 should be moved here. So how to do that same thing programmatically? See, I should start from last index 7, then standing there, I should copy the element from 6. So 10 will be copied here. Then move down to this location. Standing here, copy the element from this location. So 9 will be copied here. Then move I here. Standing here, copy the element from this index. So 6 is moved here. Then move I here. Then this is the place where we want to insert. So stop. When it became that equal to 4, then stop and insert the element there. So for that, I will write on the code. I has started from 7, that is length. So let I is starting from length. So I have to do this repeatedly. So let us say for. Then how long it should continue? While I is greater than the index that I want to insert at. So this is index and this is x. So index. Then I should be decrementing every time. Then as I said, when I was standing here, so it has copied the element from here. So at a of I, we should copy the element from a of I minus 1. That's it. So being at index I, copy the element from index minus 1. Then move I, decrement I, then copy the element from this index. Then decrement I and copy the element from this index. So being I kept on some index, I is on some index and copy the element from the previous index. So this process has to continue until I reaches this particular index. So when I has reached here, then simply we can insert this element 15 there. So at A of index, means the index at what we wanted, copy the value 15. So 15 will be copied here. Now once this 15 is copied here, the number of elements has increased by 1. So this 7 should become 8. So it means I should also increment length plus plus. So that's how we can insert a new element at a given index by shifting the other elements and providing a free space for the new element. Now one more thing we should take care here before performing the operation. This index should not be beyond the length of an array. See, total elements I have from 0 to 7, total 8 elements I have. And if I say that I want to insert at index 10 or 11, it should not go beyond length, or even it should not go beyond the size of an array. That condition we should check first. If it is valid, then we should perform this operation. So we'll be taking care of all those things when we write down the complete program. Now let us analyze this one. How much time it has taken for inserting an element? So what is the work done? The work done is shifting of elements, then copying of element. Copying of element is a constant time, but shifting of elements, how many elements we are shifting? See, it is possible that right now there are 8 elements and I want to insert at index 8. So no shifting required, simply the element will be inserted here. So there may not be any shifting at all, that is 0 shifting. Or I want to insert an element at index 0. So index 0 means I should shift all the elements. So, and maximum shifting can be n. So we don't know how much shifting may be required. So either 0 shifting or n shifting, depends where you want to insert the element. If you are inserting at the end of an array, then no shifting is required. At the beginning of an array, then all the elements present in an array, that is, let us say n elements, all n elements we have to move. So the time taken by this procedure or this function is order of 1, that is minimum, and order of n, that is maximum. So minimum time is 1, maximum time is n. So whenever we mention the time, we try to talk about maximum time taken by any function or a procedure. So this procedure takes order of n time, but it is having minimum time as well as maximum time. So minimum time taken, we can call it as basic case time, and the cases we are inserting at the end of an array. And the maximum time can be called as worst case time, and the worst cases we are inserting at the beginning index of an array, that is index 0. So that's all about inserting an element at a given index. So we have finished this one. Now let us talk about deleting an element from a given index. In this video, we will see append function and insert function that we have already discussed. So already I have written this program. I have shown you this is structure, and this modified one, I have taken array of size 20. Let us make it to 10 so that we can see the contents easily inside debug area. And inside main function, already array is initialized and the size is 10, and also the present elements are 5. Now here I will write on a function for append. This append function will insert a new element at the end of an array. So it should take a structure array. As it is going to modify the array, it should be a call by address type, and this X is the value that we want to insert. Now append means just we will be inserting a new element at the end of this array. Right now the elements are 2, 3, 4, 5, 6. So a new element should come after 6. So before insertion, first of all we should check whether there is sufficient space or not. If ARR arrow, that is caps, length is less than ARR's size, then there is a free space available. Otherwise we cannot insert any element. So for inserting an element in an array A of ARR's length. So we can insert it at a position length and also increment length. The value X should be stored. That's all, end of the function. I will call this append function inside main function by passing address of ARR and the value that I want to insert is 10. After inserting the value, this display function will display the value. I should get the values that are 2, 3, 4, 5, 6 and 10. Let us run. Yes, the elements are 2, 3, 4, 5, 6, 10. So this display function is displaying all the elements up to the length of an array. Let us debug this program and see at the append function I'll put a breakpoint, then I will run. Yeah, here inside the debug area you can see the elements in an array are 2, 3, 4, 5, 6. And it's about to call append function. Let us go to append function. It will check the length and the size. Then it will store an element in an array. Now if I expand this array object, you can see that after 6 a value 10 is also stored. Back to main function, then display will display all the elements. So that's it, we have seen how an element is stored in an array. So this display will display the elements that we have already seen it. So let us stop the function. Now next thing, we will write a function for insert. We have already discussed a function for insert, so above the main function I will write a function for insert. So the function for insert returns void and the function name is insert, and it should take a parameter of type array by address because it's going to modify an array. The next thing is index at which we want to insert an element, and last is the value that we want to insert, the element that we want to insert. Before insertion, let us check whether the index given is valid or not. A valid index is from 0 to length of an array. So here I will check if index given is greater than or equal to 0 or not, and also this index should be less than or equal to ARR's length. This is valid index. If the index is valid, then only we'll perform insert operation. So for performing insert operation, we need a for loop. So for that, I will declare a variable I. Now here using for loop, we will shift the elements and provide a free space for a new element. Then we will insert it. I starts from ARR length greater than given index and I minus minus. I am writing the same code what I have shown you on whiteboard. And at A of I, as A is inside an array object, so I have to use arrow operator for accessing it, A of I minus 1. So the previous element we will copy it here at the current place. Then after this, in an array at A of the given index, we can write down an element, and also ARR's length should be incremented because we have inserted a new element. That's all. This is the insert function. Now let us go back to main function. Inside the main function, I have already shown you how to use append. Now let us see how to use insert function. For inserting, I have to pass array as a parameter, that is by address, and the index that I want to insert at index 5, that will be last index, and the value that I want to insert is 10. Then after that, all the elements will be displayed. So this 10 should be inserted after 6, because if you see the indices, this is 0, this is 1, this is 2, this is 3 and 4. At 5th index the element will be inserted, that is after 6. Let us run and check. Yes, 10 is inserted at the end. I will change the index. I will insert it at index 0. Let us run it again. Yes, 10 is inserted at index 0, that is the beginning index. Let us change the index once again and see 2. 2 means it should be inserted in between 3 and 4, that is after 3. Yes, it is in between 3 and 4. The value 10 is inserted. Now let us give the index as -2, then let us see what happens. I run again and the values are displayed. So 10 is not there. I'll give the index 9. Now let us run the program. See, still 10 is not inserted because the index was invalid. So that's all. In the remaining videos, I'll be using the same program. So it is having all the functions and the structure of an array available here. Delete operation is removing an element from a given index. Obviously, when we want to delete something, then we should mention which element we want to delete. So we can mention index. So as an example, I have taken delete element 3 at index 3. So this element I want to delete. So for deleting this element, so first of all, you take out the element from there. So taking out an element, so I can take out x assign a of this index, whatever the index is given. Now we have an element that we want to delete that is present here in x. So let us say 12 is present in x. So we have taken out the copy of an element. Now when we say this element is not there in the array, then this space will be blank. So remember this, we don't leave blank spaces in between the elements in an array. So if we are saying that that element is not there, then we don't know what all the other elements are there or not there. So then it becomes difficult for us to find out whether the element is there or not there. When we delete the elements from an array, then that space we don't leave it vacant. If we are leaving it vacant and assuming that the element is not there, then for every location we have to check whether the element is there or not there. So it increases our work. So instead of keeping that space blank, we will shift all the elements. So whenever we delete an element from an array, we have to shift the element to occupy that blank space. So what I have to do is shift the elements from here. So being here, let us again take I, which will shift the element, then move I and shift the element, then move I and shift the element. So it's going in forward direction now, and move I, then shift the elements. I should not move further because this is the last index where I have an element that was length -1. So I should stop before length -1. So I should shift all the elements one by one, starting from a given index and reach till length -1 location or before length -1. So the shifting of these elements can be done using for loop. So let us start I from the given index, and being I here, it can copy the element from the next index. So let us write a for loop for I starts from given index. So this is the index is 3. So from index, and where I should stop, it should stop at 6. Being at 6, it can copy the element from index 7. So I should be less than length. See, actually length is 8. Less than length means 7. No, it should stop at 6. So length -1. And I is moving forward every time. So I plus plus. Now what I has to do? Being here, it should copy the element from next index. So at A of I, it should copy the element from A of I plus 1. That's a loop. Now with this loop, I here at index 3, it will copy 15, then I plus plus, then being here, it will copy 6, that is +1 is copied here, then I plus plus, now I is here, so it will copy the element from next index. So it is at 6. So it is at index 5, so it will copy 9, then I plus plus, it should copy 10. Then after that, I should stop. Yes, I is less than length -1. Length -1 is 8 minus 1, that is 7. So I is 6 now. 6 is less than 7. So if it becomes 7, it will stop. So this has moved all the elements or shifted all the elements. So this element is removed. Now as the number of elements has reduced, so this should become 7. So here I should decrement the value of length minus. So this is the pseudocode for deleting an element from a given index. Now one more thing we should take care that the index should not be out of the range like I have only 8 elements, I am giving index as 10 or 12. Beyond the length of an array, it should not go beyond the length. So that you have to take care. So that we'll be doing it when we write the program. Now let us analyze how much work is done here. What is the time complexity? See, copying the element from a given index takes 1 unit of time, and decrementing length takes 1 unit of time. And this loop, the statement that is shifting the elements, how many elements are shifted? So it depends what index I have given. So minimum 0 elements are shifted. If I was deleting the last element, then nothing has to be shifted. If I am deleting the first element, that is index 0, then all have to be shifted. So minimum shifting is 0, maximum shifting is n. So minimum shifting is 0 or maximum shifting is n. So again, the minimum time is a constant and the maximum time is n. So if I write minimum time is 1 plus 1, that is 2, and the maximum time is 1 plus 1, 2, as well as n. So n plus 2. So the best time is 2, that is constant. Worst time is n, that is maximum. So best case is what? If I am deleting the last element, no shifting required. Now right now, if I delete 10 from here, if I want to delete 10 from here, then directly 10 is deleted. No elements beyond 10, so no shifting required. So the best case time is order of 1. Worst case time is order of n. So that's all about deletion. So we have finished deletion. Now next will be search. So we'll learn about search. In this video, we will see delete operation upon an array. So I'm using the same program which we have already used for insert, append and display. This is the array structure, having array of size 10 with the size and length. So here, just above main function, I will write a delete function. Delete function will delete an element from an array from a given index. So it should return a deleted element, and the function name is delete. It should take a parameter of type array, and it should be called by address because it's going to modify an array. And the next thing is it should take an index from where we want to delete an element. Here I am getting an error because function should return something. So I will write return 0 for time being before writing the code. The error is gone. This IDE shows instant error. So wherever there is an error, that time only it will highlight the error. That's the benefit of this IDE. For deletion, I should take the value, deleted value in this variable. So I will make the variable initially 0. Then before deletion, first of all, I should check whether the index given is valid or not. So index should be greater than or equal to 0, and index should be less than equal to ARR's length minus 1. So or else I can say just index is less than ARR's length. So because if length is 5, we'll be having the last element at index 0. So this is the condition I have to check whether the index is valid or not. If the index is valid, then in variable x, get the value from array at a given index. Then I have to shift the rest of the values. So for that, I need one more variable I. I have declared the variable I. Now here, I will write on for loop for shifting all the elements. For I assign, from index onwards, I should start, and I should be less than ARR's length minus 1, because we are shifting the element, so we should stop at a length minus 1 and I plus plus. At every time at ARR's I should copy an element from A of I plus 1. This will shift all the elements. Then after shifting the elements, the length of an array should be decremented. So it is decremented. And I should return the value x, whatever the value is deleted. And here also, I can write x, that is x will be 0, or else I can write just 0 also. Means if the element is not found, means the index is invalid, then it will return 0. See, this is the extra condition I have written, checking whether index is valid or not. This I did not discuss in whiteboard session. Now, coming back to main function. Inside main function, I will call delete function. Delete will return the value that is deleted. See, here it returns integer type. So that value, I will directly print it. So let us write printf %d new line, then call delete function by passing address of array, and index I want to pass it at index 4. So last index is 4 and the value present there is 6, so I want to delete this value. Then after this, the length of the array will become 4 and I'll be having only 4 elements, that is 2 to 5. Let us run the program and see what happens. Yes, value 6 is deleted, and now display function is displaying only 4 values because only 4 values are there. Let us give a different index. Index as 0. I'll give index 0. Let us run the program. So value 2 should be deleted and the remaining values in an array are 3, 4, 5, 6. Let us debug this delete function. I'll put a breakpoint on printf and run the program. Now watch here the debug area. The values are 2, 3, 4, 5, 6 and the value that I am deleting is index is 0. If I continue running, then what happens? Just watch it. It has entered into delete function. I will expand this array object so that we can see the contents of an array A. See, now for loop starts, so it will be shifting the values one by one. See, 3 is copied here. Now at these two places 3 is there. So this 3 is copied here, 2 is gone. The next 4 will be copied here. So this 4 remain as it is unless it is removed. So we can't remove it. So this 4 will be copied here next. This 4 is copied. Then 5 is shifted. Then 6 is shifted. You can check the length also here at the bottom. Length is 5. 6 is shifted. Then length became 4. That's all. It will return back to main function. And the value is printed, deleted value is printed, and the display function is called. So that's all with this delete function. Let us look at search methods in an array. There are two search methods. One is linear search and the second one is binary search. So in this video, we'll look at linear search, and in the next video, we will talk about binary search. So let us look at linear search. Here I have a list of elements. I have taken a list size or array size as 10 and the list size is also 10. Now here I have taken unique elements. So for performing search, the elements must be unique. There should not be any duplicate elements. If there are multiple copies, then if you are searching, we may be getting any one of the copy. May not be able to reach another copy of it. So there should be unique set of elements. Then in a list, if I want to search for any key element, so the value that we are searching, usually we call it as key. So suppose I am searching for a key that is 5. Let us look at linear search method. In linear search, we search for the key in a list linearly by checking the elements one by one. For searching 5, we will start comparing from first element onward. Is it 5? No. Next, go to the next element. Is it 5? No. Go to the next element. Is it 5? No. 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 Yes, it is found here. We already know the element that we are looking for, that is 5, and we want to know where it is present. So we got the index, that is 7. So usually the result of a search is the location where the element is found, so that we can access that element. Now let us take one more key element and search it. So this time I'll take the key element. Key is 12. Let us find out whether 12 is present or not. So we'll follow the same procedure. We'll start from the very first element in the list and compare 12. Is it 12? No. Go to the next element. Is it 12? No. Go to the next element. The next, and even this is not 12. This is not 12. Then we have reached the end of a list. So if we have reached the end of a list means element is not found. If the element is not found, search is unsuccessful. So if the key element is found, we say search is successful. If it is not found, then we say it is unsuccessful. So this is successful. This is unsuccessful. So key element is found, this search was successful. Key element is not found, so this search was unsuccessful. So when you are searching, you have to take care of both the things, whether the element is found or not found. Now let us write a pseudocode for performing linear search. So for searching for a key element, we start comparing the element from the 0th index onwards, and every time we move on to the next element. So it is just like traversing a list. This can be done using for loop, or even if you want, you can use while loop. So I'll first show using for loop. So for I start from index 0, so I should start from index 0, and till where I should go, till the end of a list, and the index is 9. So that is length. Length is 10. So it is length minus 1. So I can say I less than length. So I should traverse the whole length of a list. And every time I should be moving forward. So I plus plus. Then what I have to do? Every time wherever I is, I should check that if the key element is equal to A of I. So if key is equal to A of I, if it is equal, then search is successful. So we got the element. So once you got the element, what we want the index where the element is found. So here we can say return index. So who is giving index? I. So wherever I is present, that is index. Return I. That's all. So let us see how it works. I is initially 0. Suppose the key value that I am looking for is 5. Then it will check I is less than length. Yes. Key, is it equal to A of I? That is key 5. Is it equal to A of 0? 8? No. So it will continue and say I plus plus. I will move to the next index. Then here it checks key, is it equal to A of I? 5, is it equal to A of I? That is A of 1? 9. No. So it will go to the next. So it will continue. And once it reaches here, now this time key is equal to A of I. Yes, 5 is equal to A of 7. Then return 7. So this is in case of successful search. Now what happens in case of unsuccessful search? Let us see. Initially I is 0. Suppose we are searching for 12. First it will check that key is equals to A of 0. 12, is it equal to this one? No. Then I will move to the next element. Then check key is equal to A of 1. A of 1? No. Then again I plus plus, I moves to the next element. Then again check 12, is it equal to A of this? No. So in this way it will continue, and this condition will never be true. So I will move to next, then next, then next, then finally let us take this. I is less than length. Yes, length is 10 and I is 9. Yes, it is less. So key, is it equal to A of I? 12, is it equal to 2? No. Then continue I plus plus. I will move to the next location. Now I became actually 10. This I became 10, and 10 is not less than 10. So it will come out of the loop. So if it is not finding a key element, then it will come out of the loop. If at all key element is found, then it will return, means stop the procedure here itself. So if the key element is not found, then it will come out of the loop. Then outside the loop we can say return. Now, if the key element is not found, then we have to return something to show that element is not found. So the invalid index, that is -1. So we can return -1. So usually we do it like this. If the element is not found, then the return index is -1. So if you are calling this procedure, then if you got -1 means element is not found. If you got a valid index means element is found. So that's how you can know whether the search was successful or unsuccessful. So this is about linear search. Let us analyze, find out the time complexity of linear search. So one thing I will tell you about time complexity. So for finding the time complexity, either you can observe the work that is done or else you can read the code. So let us see from the procedure. What we are doing for searching: key element, checking, next check, next, next, next. So we are comparing the elements. How many elements we are comparing? At most how many? See, if I am searching for 2, then I may be performing all n comparisons, means depending on the number of elements. Or if I am searching for 8, then I may be getting an element in just one comparison. So if you look at the code now, this loop may repeat up to the end of a list, or if at all the condition is satisfied in the beginning itself, it may terminate. So this loop may repeat minimum for one time and maximum for n time. So the best case is that if the element that we are searching is found at first place and the time is order of 1. Best case time is 1. And the worst case is if you are searching for an element which is present at the last index and the time is order of n. So worst case is searching for last element, or the time taken for worst case is order of n. This is case of successful search. What about unsuccessful search? If the key element is not found, then always it will check all the elements, then only it can inform you the element is not there. So for unsuccessful search, time is always order of n. It's maximum time, always maximum time. So unless you have reached the end of the list, you cannot say that the element is not present in the list. So the time taken is order of n. So this was the best case and worst case I have shown you. Now one more thing. Let us look at average case time also. Average case time may not be easy always, so we may not be performing it always because it needs a lot of efforts for doing analysis. So mostly we are dependent on worst case or also best case. Now let us see average case. Let us check. So best case is searching for an element present at 1. Worst case is searching an element present at last. Then these are two cases. What are the other cases? Searching for an element present at index 1, that is second element, or the third element, or the fourth element, or the fifth element. So these are all possible cases. Then what is the number of comparisons done for checking if the element is present? Then what is the number of comparisons required if you are searching for first element? Just one comparison required. Then what about the element at second location, that is index 1? Two comparisons required. So the case if you are searching for this, it needs two comparisons. In case if you are searching for this, it needs 3 comparisons, so on. Then if you are searching for last element, n comparisons are required. So I have taken the time taken in all possible cases, and I have taken the total time taken in all possible cases. So sum of the times taken in all possible cases. Then total how many cases are there? N elements are there. So n cases are there. So this is n. So sum of the time taken in all possible cases divided by number of cases. This is equal to n into n plus 1 by 2 whole divided by n. N gets cancelled. So this is n plus 1 by 2. So this polynomial is degree 1, that is order of n. So the average case time is order of n. So we have found the average case also. Now, let me say something here. See, usually finding average case time needs a lot of analysis. So you have to consider all possible cases, identify them, take out the time and add their times and divide them by number of cases. This is a little tedious work. And sometimes we may not be able to get some proper solution. So mostly we are dependent on worst case, because usually worst case and the average case will take same amount of time, almost same amount of time. So worst case is easy to analyze. So mostly we do worst case analysis. So this was the analysis of linear search. Now let us see improvement in linear search. Is there any improvement possible? Let us check. So it is observed that when you are searching for any key element, then there is a possibility that you search for the same key element again. For example, if you have a collection of books in a shelf, that is your personal collection, you have searched for a particular book and you take out the book and read it, again you keep it back. What is the possibility that again tomorrow you will search for the same book? The possibility is high. So that's what in the search, the behavior of search is that when we search for something, possibility that we search for it again. Then when we are searching for 5 How many comparisons it has taken? Total 8 comparisons we had performed to reach 5, that is 0 to 7. Now if we are searching for 5 again, then what we want is it should be searched faster. So there are two options. One option is you can move a 5 to the previous location, just one location. You can swap 5 with the previous element. So it will reduce by one step. So second time when you are searching, you have to perform one less comparison. Then again if 5 is searched, then again it will move. So every time whenever you are searching 5, then it will be coming closer and closer. Now 5 is moved here and 10 is moved here. So let us write like this, 5 and then 10. Now again if you are searching for 5, then 3 will go there and 5 will come here. So if you again search, it will again move closer. So you can move a key element which is repeatedly searched, you can move it one step forward. So this method is called as transposition. So that transposition you can do it here. If that key element is found, then you can swap that key element with a of I with a of I minus 1. And now your key element has index I minus 1. Then you can return I minus 1. So this one statement you can add inside search procedure. So if the element is found, so it is moving one step forward so that next time it can be searched faster. This is one method. Now second method I will show you. Second method is if you are searching for a key element which is found here after performing 8 comparisons, then once it is found, you bring it in the beginning. Swap it with the first element. If you are swapping with the first element, the next time when you are searching, it will be found just in constant time. So this method is called as move to front or move to head. It is also called as move to head. Move to front or move to head. So this is another suggestion or another guidelines for improving linear search. So here in this code, if the key element is found, then we can swap the element with index 0. And now the new index is 0 for this element. So 5 is brought here. Let us assume 5 is here and 8 is here. So the key element that we have searched is brought in front. So you can return index 0, that the element that's index 0. So this is another method. In transposition, the elements will be moving slowly forward, or if it is not searched, then it will be slowly moving back. This is how it behaves. Then in move to front, if the element is searched, then directly it is brought into the first position. Suppose now if you search for 2, then 5 will be sent on that index 9 and 2 is brought here. So we don't know where the present element like 8 will be thrown away. But the new element will be brought at that index. So then again this may be thrown away somewhere else if you're searching for some other value. In transposition, there is a slow reduction in the time taken for searching. And in move to front, there is a sudden reduction in the time taken for searching. Next time if you are keeping on searching, it will be done only in constant time. So that's all about linear search and in its analysis. In this video, we will implement linear search and also improvement of linear search by applying various methods. So already I have an array here with a few values, that are 5 values I am having. Let us use same values for the program. So here above the main function, I will write a function for linear search. Linear search should search for an element and return its index. So function name is linear search. It should take an array. So struct array arr. See, I'm not passing it by address because just by value is enough, because it has to only search for the value. Then the key that we want to search. That's all. Now the program is very simple. I need a variable I, and using for loop we can check for the element. I assign 0 and I is less than length. So arr dot length I can say, because this is coming called by value, not called by address, so I don't have to use arrow. Then I plus plus. Every time I should check whether that given key is equal to element in an array at index I. If it is found, then return index I. Otherwise, after the for loop, we can return index -1 saying that element is not found. So logic is very simple. We have already seen this. Now here I will call linear search function and the result I will directly print it. So I will use printf %d/n and I will call linear search function. Parameters are array and the key value that I want to search is 4. Now 4 means I should get the index as 2. Let us run. Yes, index is 2. The key is found at index 2. Next I will search for 6. Yes, key is found at index 4. Let us give the value 15. It is not there. Index is -1. Yes, element is not found. So that's it. This is a function for linear search. We have also seen how to improve linear search by using transposition or move to front. So let us adopt those techniques. So in that, just we will swap an element with the previous element or with the first element. So for that, I will write one function called swap, which will swap two elements of type integers. So first is pointer x and second is pointer y. I will write this function, so wherever I need to swap the elements, I'll use this one. So temporary variable, then temporary variable assign the value from x, and the value of x is modified by value of y, and value of y will change to temp. That's all. These three lines for swapping two elements, I'll be using it whenever required. This is called by address. Now let us improve linear search. For improving linear search is going to modify this actual array. So for modifying this actual array, this should take address. So it should be a pointer, and here while calling, it should be an address. Then when I'm accessing the members, I should use arrow instead of dot. Now these changes I have made so that it can modify the actual array. Now before returning the element, we should swap the element. So first of all, let us see transposition. So transposition will swap the element with the previous element. So let us call swap function here by passing address of a of I with address of a of I minus 1. So it will interchange the element found at index I with element at I minus 1. So here I will debug the function, then we can clearly see how it will perform transposition. And I will search for a key element, that is 5, searching for 5. So 5 should be interchanged with 4. Let us run. I'll put a breakpoint here on printf and run. It has stopped at printf function. Let us continue. Now it has entered into linear search. Let me expand this array. It is searching for the key. It's going on the next index. The next index I is 2 now. At the bottom you can see I is 3, then the element is found. So it is swapping the elements back to this function. Now you can see that 4 and 5 has interchanged their places. So 5 came before 4. So this swapping is done and return the element. So that's all. Back to the main function. I'll remove the breakpoint and continue normal execution. So index return is 3 and the elements are changed, modified. You can see that the elements are modified. 2, 3, 5, 4, 6 now. Now next we will see move to head. So I have to just make a small change in this linear search function. I have to say swap a of I with a of 0. Just say 0, the element will be brought at index 0. Let us run and see. 5 should be brought at index 0 and 2 is sent in place of 5. Yes, you can see this change in the list of elements. So that's all about linear search. Now let us look at binary search. For performing binary search, the prerequisite or the condition is that the list of keys or the elements must be sorted. So I have taken sorted list of elements, total 15 elements I have taken. Array size is also 15 and the number of elements are also 15 and they are sorted. So this is the first and foremost condition. So why it is called as binary search? Because it will always check for a key element in the middle of a sorted list and it will split the list into two. So that's how it is binary search. So let us see the working. For example, I have taken a key element 18 which is present here. We will search for this element. If I am performing linear search, in how many comparisons I can find 18? 1, 2, 3, 4, 5. So in 5 comparisons, I'll be reaching there. Now let us see how binary search works. So for performing binary search, we need 3 index variables. So those are lower, higher, and mid. And this mid is low plus high divided by 2 and we will take the floor value. Now using these three we'll perform binary search. So what is low? Low should be initially pointing on index 0, that's the beginning of a list, and high should be pointing on the end of a list. So as per our example, low is 0, high is 14. This is initial. Now let us perform repeating procedure. Find out mid. 0 plus 14 by 2, 0 plus 14 by 2 is 7. Mid is 7. Mid is 7. So if low and high are given, calculate mid. Now check if this 18 key element, is it present here? No, this is not the key element we are searching for. Then our key element, is it smaller or greater? It's smaller. So it is on the left hand side. How you can say that? Because the list is sorted. So if the key element that we are searching is greater than this one, then definitely it is on the right hand side. But our key element is 18, so it is on the left hand side. If it is on left hand side, then reduce the list into half. Our list was from low to high till there. Now it should be from low to this point. Already this element we have checked, right? So up to this point. So move high to mid minus 1. So high should be moved here. So this should be high. High should be changed to 7 minus 1, that is 6, and low remains 0 only. So now we have split the list into 2 halves and we are checking for an element in 1 half because the other half element cannot be found. Now continue. Find out mid. Mid is 0 plus 6 by 2, that is 3. So new mid value is 3. Is it the key element that you are searching? Our element is 18. No, this is 15. So key element is greater. So it is on the right hand side of the list. So this is the present list now and this is mid. So the element is on the right hand side, means in this portion. So change this low to mid plus 1. Already we have checked this element, so don't include this one. So low should be brought on 4. So low should be changed to 3 plus 1, that is 4. And high remains 6 only. Now find out new mid. Mid value is 4 plus 6 by 2. This is 5. This is mid. Check. Is it the key element? 21. This is 18. No. 18 is less than 21. Then check on which side of the list. Check on the left hand side of the list. You can observe that the list size is getting reduced and every time it is getting divided by 2. So for checking on the left hand of a list, modify this high. High should be what? Mid minus 1. Don't include this element. So it means low was already 4. High will also point on the same location. So mid minus 1. So 5 minus 1. So 4. High is 4. So low was already 4. Now find out new mid. 4 plus 4 by 2 is a 4. So mid is also 4. Now check. Is it the element that you are searching for? Yes, element is found at index 4. Element is found. Search is successful. So this is how binary search work. Total how many comparisons it has found the element? 1, 2, 3, 4. In only 4 comparisons we got the element. Let us take one more key and search for it. I am taking key 34. So key is 34. The values that we need are low, high and mid. So already you know the formula for mid. Now let us start. Initially low is here and high is here. So low is 0, high is 14. Find mid. Mid value we always get same thing. 0 plus 14 is always 7. So mid will be here. So for this list mid is always same. Anyway, let us check what is the number there. Is it a key 34? No. Key is greater than this one. So key is on the right hand side. So change low to mid plus 1, that is 8. Now this is the list in which we have to search. So low will change to 8 and high will remain 14. Now again calculate mid. Mid is 11. So mid will move to 11. So we are on the right hand side. So the list is divided into half and we are checking on the other half of it because the number cannot be on the first half. Now check, is it the number that we are searching for? No, 34 is smaller than that one. So it should be checked on this side. So modify high to 10. So high becomes 11 minus 1, that is 10, and low remains 8. Now find out mid. Mid is 9. This is mid. Is it the number that we are looking for, 34? No, that is 33. So the number is definitely on the right hand side. So modify low to mid plus 1, that is both will come on the same place. 9 plus 1, 10, and this remains 10 only. Now find out mid. Mid is again 10 only, so mid points on same thing. Yes, this is the element. So we got that element in 4 comparisons, 1, 2, 3, 4. 4 comparisons, element is found at index 10. So this is how we have seen 2 examples in which search is successful. Now let us take one example for unsuccessful search. I'll take one element which is not present here. So I'll take value that is 25. 25, it should be after 24 but it's not there. So let us take a key 25 and check it. Key is 25. Low, high and mid. These are the 3 values we need. Low starts from here, high starts from here. Now first mid value is 7, so 0, 14 and 7, mid is here. Now is it a key? Key is 25, so this is not 25, 25 is smaller, so check on the left hand side. So move high to 6, 7 minus 1, that is 6, and this is 0. Now mid is 3. Go to mid of this one, so this is the middle of this list. From low to high, this is the middle one. Is it the element that we are looking for? 25. 25 is greater. So check on the right hand side. So this will be new low, that is mid plus 1. Low becomes 4 and high remains 6. Now find out mid, that is 5. So this is mid. Now, is it the number that we are searching for? 21? No. 25 is greater than that. So 25 is on the right hand side. So modify this low and low also becomes 6, that is mid plus 1. So 5 plus 1, this is also 6 and this is also 6. Find mid, this is 6. So right now, low and high and mid, all of them are on 6. Now, is it the element that we are checking for? 25? No, 25 is greater. So modify low. If it is greater, we'll modify low. So low will become what? Mid plus 1. So what is mid right now? It is 6. So low will become 7. So mid plus 1, low will become 7 and high is 6 only. Now we will stop. We will not find mid now, we will stop. Reason, low has became greater than high. Low has became greater than high. Low should be on the left hand side and high should be on the right hand side. But low became greater than high. So it means the element is not there in the list. So search is unsuccessful. So this search is unsuccessful. So these 2 keys were found and they were there in the list. 25 is not there in the list. Now let us see how many comparisons it has taken. 1, 2, 3, 4. 4 comparisons, and here we don't do anything, stop. So in 4 comparison we got the result that element is not there. So this is how binary search works. Now let us write the algorithm for this one. So I will write the algorithm for binary search. The syntax may be more like C++ syntax, but I am writing pseudocode. Algorithm binary search. So what are the parameters it needs? It needs 3 parameters: low, this one, and high, and key value that we are searching. So which key we are searching? So this is key. So these were the parameters. Then what we were doing every time? We were finding out mid. Mid is low plus high divided by 2, and we have to take the floor value. Then we were checking whether the key is present at A of mid. If a key is equals to A of mid. If you remember, we were getting the middle element, this one. So we were checking whether this is the key element that we are searching for. If so, suppose we are searching for 27, then it is found. It is found. So return the index mid. That is, this is the index, it is found. So return it. No, if the key element is smaller, then check on the left hand side. So else if key is less than A of mid. So if it is on left hand side, we were modifying high to mid minus 1. So high should be changed to mid minus 1. If it is not equal, if it is not less, then it must be definitely greater. So we have to check on that side and modify low to mid plus 1. So modify low to mid plus 1. So else we will modify low to mid plus 1. This is what we were doing. So we have to go on doing this until the element is found. Or if the element is not there, we should stop when low becomes greater than high. So this means we have to do it repeatedly. How long we should do this? While low is less than or equal to high. We should continue this. So we should stop when low becomes greater than high. If low became greater than high, then we stop, means the element is not found. So we can return minus 1, saying that the key element is not found. So this is a iterative procedure that is using loop for binary search. I have just shown the algorithm or pseudocode, though it is more like C++ code, but the perfect executable code I will write down when I show you the program. This binary search algorithm is written using loop here, that is iterative version. We can also write a recursive version. So let us write a recursive version for performing binary search. Algorithm R binary search. What are the parameters it needs? Same parameters, low, high and key. So low, high and key. These are the 3 parameters. Now as it is recursive, so it will be calling itself. So what is the first thing we should check? Whether there are some elements or not. So we should check that low should be less than or equal to high. If low is greater than high, we cannot perform anything. So we will check first thing, that is if low is less than or equal to high, then only we will consider. So if low is less than or equal to high, at least there is one element. If low is greater than high, means there are 0 elements. So first condition we check. Then after that we will find out mid, and mid is low plus high divided by 2, and that is floor value, and we check if key is equals to A of mid. If so, then the element is found, so return mid. So it is similar. Almost it is similar. Else, if the element is on the left hand side, check if key is less than A of mid. If key is less than A of mid, then we have to search on the left hand side. So this procedure can call itself recursively for searching on the left hand side. So say return R binary search, R bin search. So this is recursive call. So this is recursive call. So what it has to pass? Low as it is, but in place of high, it should be mid minus 1 and key as it is. So this is a recursive call with modified list or reduced list. So it is just passing left hand side list. So if mid is here, from low to mid minus 1, it will be passing. So if the key is less, it is on the left hand side. Otherwise, key is greater and it is on the right hand side. So else return R bin search mid plus 1 and high as it is and the key also. That's all. If low is less than equal to high, do all these things. If low is not less than equal to high, then return minus 1. Means key is not found. So this is a recursive procedure for performing binary search upon an array, and assume that array is global. So I am not taking any parameters here. Otherwise, array should also be taken as parameter. If it is not there, means we should assume that it is global in algorithms. So these are the iterative procedure as well as recursive procedure. Now if you observe that recursive algorithm, it is tail recursion. See, at returning time, there is nothing. Either it performs this recursive call or this recursive call. And after the recursive call, so there is nothing it has to perform. So it has to check for the element that it is checking beforehand only. So in this portion, it is checking for the elements, right? It is checking for the elements. Then after that, it is calling itself. So at returning time, it's not doing anything. It's not doing anything. So instead of writing a tail recursion, you can also write a loop iterative version. So already we have discussed that tail recursion and loops are similar. So if you have to write tail recursion, better go for loop. So this procedure is better because this uses a stack. Internally it uses a stack. Now next we will do the analysis of binary search. In this video we will see binary search functions. I will write iterative version as well as recursive version. So first of all, let us write a iterative version. Binary search, it should take a parameter that is array, and it's going to just access the elements. It's not going to modify them. So call by value is sufficient, and the key that we want to search. Now for performing binary search, we need following variables: low, mid, and high. Low should be initialized with 0 and high should be initialized with length minus 1 because the last element is present at length. So length minus 1. So these are initialized. I will write return 0 to avoid this error. Then the procedure is using a loop while low is less than or equal to high. Find out mid. Mid is low plus high divided by 2. Then check if the key is same as A of mid. If it is same, then we got the element and return its index. The index is mid. Else if key is less than A of mid, then we will modify high value to mid minus 1. Else definitely it is on the right hand side, so we'll change low value to mid plus 1. That's all. In this loop, it will check for the element. If it is found, it will return its index. Otherwise, if it is outside the loop, means we should return minus 1, saying that the key element is not found. So this is the same code what we have discussed on whiteboard. Few changes are there like parameter and these low, mid and high, which I have declared them. Now let us call this function inside main function. So I will directly show its result. So I will use printf %d /n and I will call binary search function by passing array, and the key that I want to search is 5. Let us run this. I got the index 3. Yes, see, this is 0 and 1, 2, and this is 3. I will change the key value to be search. I will give the value as 2. Let us run this. This index is 0. Yes, correct. I'll give the key element as 10. 10 is not there in the array, so I should get index minus 1. Yes, index is minus 1. That is, key element is not found. I'll give the element as 15. Let us run. The element is not there, so it should return index minus 1. Yes, index is minus 1. So that's all with this binary search. Let us write a recursive binary search function which takes parameters low, high, and the key value. But here I will also pass an array. So let me write down the function name as bin search, r bin search. It takes 3 parameters. First is an array, low, high, and the key value. These are the parameters we'll be passing. And here I will write down return -1 to avoid the error. Now inside the function we also need a mid. Then I will write on the procedure that we have seen. If low is less than or equal to high, then only we will check for the key. And the method for checking a key is first find out mid, that is mid is low plus high divided by 2. And check if key is equal to A of mid, the array middle location. If so, then return mid. Else, if key is less than A of mid, then we will check on the left hand side. So I will write return r bin search. I will pass array A and low as it is. Instead of high, we will pass mid -1 and the key as it is. Else, we will return. Now we have to check on the right hand side, so I will say r bin search array as it is. Low, I will change it to mid +1 because we have to check on the right hand side. High as it is, and this is key. This is the recursive function for binary search. Now let us call this r binary search from the main function. I will change this r bin search we have to pass array, so arr.a array. Then low is initially 0, definitely. Then high is arr's length. And the key that I want to search is 5. So I have sent the sufficient parameters for this r bin search. Let us run the program. Yes, we got the index 3. I'll change the key to 2 and run it. Yes, index is 0. It's working. I'll change the key to 9. 9 is not there, so I should get the index as -1. Yes, it is -1. So it's working. That's all with the binary search functions. I have shown you both iterative version as well as recursive versions. And you can debug these programs and check how the low and high values are changing and how it is calculating mid every time. So that's all in this video. Now let us do the analysis of binary search. So for the same list, if you observe, when we have searched for various keys, every time mid value was 7. Obviously 0 to 14, middle is 7 only. Initially low was here and high was here, and we were getting mid. This is mid. So always we were getting mid at 7. So if suppose we are searching for a key 27, then in first comparison only our search should terminate that key is found. So it means that key value at index 7, the key value 27 can be found in just one single comparison. And next we were searching for the element on the left hand side. So high was here and mid was this one. So for the left hand side, middle element was 15, the index was always 3. So on the left hand side, middle one is index is 3 and the element is 15. Then on that side if we check, if we are checking for an element on right hand side, then the low will be this one and high will be this one, and this we will get it as middle, that is index 11 and the element is 37. Index 11 and element is 37. So it means if you are searching for 37, then it will be found just in two comparison. First time we will check for index 7, that is 27, element is greater 37, go on the right side, take the mid, we get this mid, element will be found in two comparison. So from this list, this will be found in one comparison and this will be found in two comparison and this also in two comparison. What about remaining? So I will quickly write down about the remaining one. If I take the left hand side list, that is from 0 to 6, the middle element was 3. Then on the left hand side, if I take this list, then the middle will be 8, that is index 1. So this will be index 1 and element 8. Then on the right hand side, this list, this is the middle one, index 5. So here right hand side is index 5 and the element is 21. For this 8, left hand side is 0 and element 4, right hand side is index 2, element is 1. So if I remove this, you can see that this is on the left hand side. So this is on the left hand side, this is on the right hand side. So for this middle one is index 1, left side is 0, right side is 2. So this will be 0 and this will be 2. And the element here is 4 and element here is 10. Now this side, left hand side is 4 and element is 18, right hand side is 6, element is 24. So this is 18 and this is 24. Now similarly I'll prepare for the right hand side also. So for right hand side list, leaving this as middle, this is the right hand side and this is the mid one. So 11. Then for these three elements, this is the mid one. So left hand side is index 9 and its left is index 8 and its right is index 10. So the elements are 33, 29 and 34. And on its right hand side, these are the three elements, middle one is 13. So this is 13 and on its left hand side is 12, right hand side is 14. And the elements are 39 and this is 41 and this is 43. So this is a tracing tree we got based on the working of binary search. So we will discuss from this tree. Now if you observe, 27 can be found just in one comparison. Then 15 and 37 can be found in two comparisons. Means if the element is 15, we go on the left hand side. If the element is 37, we go on the right hand side. These elements which are at level 3, these will be found in 3 comparisons. And these elements will be found in 4 comparisons. So maximum how many comparisons are required? 4 comparisons are required for searching, not more than 4. Whether the element is in the beginning of a list or at the end part of a list, wherever the element is, maximum comparison required for searching are 4. So from the tree you can clearly see that at most 4 comparison to reach any element. So the number of comparison depends on height of a tree. This is a tracing tree, so the height of this tracing tree is log n. So the time taken will be dependent on the number of comparisons, and the number of comparisons are at most log n. So the time taken for searching in binary search is log n. So minimum time is, if you are searching for an element which is present in the middle, so the minimum time is order of 1, so you can say this is the best case. And what is the maximum time taken If the element is present here, according to this tree, if they are present in a leaf, or those elements which are reachable, they are found at fourth comparison. So the maximum time is order of log n. This is the best case time. This is the worst case time. So best case time of binary search is order of 1 and the worst case time of binary search is log n. So this was about successful search. What about unsuccessful search? Let us see. If I am searching for any element that is smaller than 4, then what happens? I'll check here. 4 is smaller than this, 4 is smaller than this, 4 is smaller than this, 4 is smaller than this also. So it will end up on the left hand side. If I am searching for any element which is present in between 4 and 8, then what happens? Let us see. 4 and 8. Let us take one element 7 and see what happens. 7 is smaller than this, 7 is smaller than this, 7 is smaller than this, 7 is greater than that. So it will end up here. So it means this node, the one which is a squared node that I am showing or representing unsuccessful searches. So this node is representing all those elements which are smaller than 4, which is not there in the list. And this represent all the elements that are in between 4 and 8. So those are 5, 6 and 7. These 3 elements it is representing. Similarly, we can represent the nodes here for all those elements which are not there in the list. So if you are searching for any element, then we say that the search will terminate at these nodes. So for unsuccessful search, this shows that it reaches at the end of a tree always. So the time taken in unsuccessful search is always order of log n. So successful search, minimum is 1, maximum is log n. For unsuccessful search, it's always order of log n. Next, we have also seen a recursive procedure. So that recursive procedure also behaves in the same way. First, it will go in the middle. If the element is small, then it will search on the left hand side, that is in the left subtree. If it is greater, it will search in the right subtree. Then again, it will call itself recursively on the left sublist or right sublist. So the maximum number of comparisons it may be making or the maximum calls it will be making will be at most 4. And if the element is not found, then it will be a 5th call. It will stop at 5th call if the element is not found. So the number of calls a recursive algorithm will make depends on the height of a tree. So that is log n. So whether you write a iterative procedure or recursive procedure, the time is log n. So how binary search is log n, I have shown you. Now I'll show you using some other method how binary search is log n. See, we have total 15 elements here, 0 to 14. 15. 15 is not in powers of 2. So I will just make it round as 16. Okay, to explain you how it is log n, I'll take it as powers of 2, that is 16. Assume that the number of elements are 16. Number of elements are 16. So how binary search is working? 16 it has divided by 2. So 8 elements this side, 8 elements that side. Assume this one. So 8 elements we are getting. Actually here we will be getting 7 elements. But as we have taken it as 16, so 8 on this side, 8 on this side. If you are searching on the left side or searching on the right hand side, again divided by 2. Then again divided by 2. So how long this can get divided? Until you are left with just one number. If there is only one number, beyond that you cannot proceed because there are no numbers. So last one, it should stop at 1. So 16 divided by 2, divided by 2 and divided by 2. So how many times I should divide 16 by 2 such that it reaches 1? So I should divide 16 by 2 power 4 so that it reaches 1. So that's all. So it means this list will be divided 4 times to reach at last one single elements. See, these were total 16 elements, assume this, half, then this half, then this half, then we got just one element. Either our search stops here or at last it will stop here. So this is 4. So the answer we got it as 4. So how do you calculate that? 16, how many times it should be divided by 2 to get the answer 1? It's nothing but 16 is equals to 2 power 4. So 4 This is nothing but 2 power 4 is equals to 16 and 4 is log 16 base 2. So actually inverse of power is log. Inverse of power is log. So 2 power 4 power is 16. Then how much is 4 is log 16 base 2. So log n. So this means the time taken is log n base 2. So when I have made it in powers of 2, so I can explain you here. Otherwise 15 means 15 by 2, 7. So we will not get exactly in powers of 2. So I have taken an example as 16. So from 16 we can observe that log n base 2. So here we can say that whatever the number of elements you have, n plus 1, then log base 2. Exact answer, we got this one. 15 elements were there, then in that you add 116, so log n base 2. So exact formula is log n base 2, and so exact formula is log n plus 1 base 2. So but roughly we take it as log n. So because the polynomial degree is log n, so we take it as log n. Then one more thing. If there are more than 15 elements, then definitely the number of comparison will increase by 1, because that is the maximum number for which we require 4 comparisons. Otherwise, if the number is greater, then it will be 5 comparisons. So that I can show you here, that is if you have 16 elements, then 16 plus 1 log base 2 is nothing but log 17 base 2. So this will be 4 point something. So suppose 4.2, then this should be taken as 5. So this value should be taken as ceil. Log base 2 n plus 1 should be taken as ceil. So I have shown you from the tracing tree, and also I have given you the idea, just the idea. This is not the method or an approach, just I have given you the idea how it is log n. Because every time getting divided by 2, so when something is successive division is nothing but log. Successive multiplication is power. That's all about binary search and its analysis. Now let us do average case analysis of binary search. So average case means total time taken in all possible cases divided by number of cases. So what are the cases? I may be searching for an element which is present here in the middle of a list or root of a tracing tree. So how many comparison it requires? Just one comparison required. Then next case is this one. I may be searching for 15 which is present here, which is in the middle of the left sublist, or 37 which is middle of the right sublist. So I may be searching this one or this one. So 2 cases. These 2 elements. How many comparisons required for these 2 elements? 1 comparison required for these elements. 1 comparison required. So I have included both 1 into 2. Then these 4 elements, how many comparisons required for each? 1, 2. For here also 1, 2. For this also 1, 2. So there are 4 elements which require 2 comparisons. Then 1, 2, 3, 4, 5, 6, 7, 8 elements which require 3 comparisons. So there are 8 elements which require 3 comparisons. So this is growing in the form. So for 15 elements we have taken an example, but we have to give it in terms of n elements, whatever the elements may be. So if you observe this, this can be written as 1 plus 1 into 2 power 1 plus 2 into 2 power 2 plus 3 into 2 power 3. So it is written in terms of powers of 2. Now this can be written as sum of I into 2 power I. So how I is taking the value? So here I is power 1, power 2, power 3. Just ignore this 1. So we can have a summation formula from these terms. So I starts from 1 to 3. So I starts from 1. What is that 3? See, this is 1, 2, 3, 4. So this is height of a tree. Height of a tree. So height of a tree is measured by taking it just 1, 2, 3. So that is log of n. Log of n. So this is approximately log of n. So this log n is the height of a tree. So as many levels or whatever the height of the tree is, depending on that many terms we have to take. So here it is 1, then 2, then 3. So this is the total time taken in all possible cases. That is sum of the times taken in all possible cases. So I have taken the total number of comparison required for searching each and every element. Then this should be divided by n, because total n elements are there. So that is the sum of all the possible cases divided by number of cases. So what is a case here? Each element is a case. Sum of the times of all the elements divided by number of elements. Then this numerator, this is approximately equal to log n. I is replaced with log n, and here also I is replaced with log n into 2 power log n, and this is divided by n. Then this can be written as log n, and this power n can be brought here. So this will be n log 2. So here we are taking the values in powers of 2. So that is log 2 base 2. So this becomes 1 and divided by n. So this is n gets cancelled. So the answer is n log n. So the average case analysis also log n. See, when we are finding average case, then we have to solve this one, summation formula. Like I already told that finding average case analysis, finding average case results is time consuming. Sometime you cannot get the exact result. We have to take approximate one. If you want, you can convert this one into integration formula and you can apply the limits and get the result that approximately this will be log n into 2 power log n only. So average case time is also log n. So we have seen best case time is 1. Worst case time is log n, and average case time is also log n. Then we'll do some more analysis on this one. Let us do average case analysis for successful search as well as unsuccessful search. Successful search is if the element is found. So that is represented by these circular nodes. And unsuccessful search is element is not found. That is represented by these square nodes. For finding the average case time for successful search, we have to consider these internal nodes. The internal nodes require how many comparison? That depends on the level. 1 comparison for this, 2 comparison for this, 3 comparison for these elements. Depends on level. But here we can count edges, the path. See, this is 2 edges away from root. So to reach here, we require 3 comparison. So the path plus 1 we can say, path plus 1. So for every node we can take the path and plus 1. So for all the nodes we can take the paths of all circular nodes. So these circular nodes we can call them as internal nodes. So let us say I is the sum of the paths of all internal nodes. I represents sum of the paths of all internal nodes, which are representing successful search. Now these square nodes, let us call them as external nodes, which are representing unsuccessful search. So let us say E is the total paths of all external nodes. So sum of the paths of all external nodes. So there is some relationship between this one. If E is the sum of the paths of external nodes, then I is the sum of the paths of internal nodes, then this is always true. E is equals to I plus 2n is always true. So a small example I will take and show you. Like suppose there are 3 internal nodes. So definitely there will be 4 external nodes. Now number of nodes are 3. Now sum of the paths of internal nodes. See, the path of this one is 1. The path of this one is 1. So total path is 2. Then for the external nodes, for this the path is 1, 2. For this also 2. So there are 4 nodes whose path is 2. So this is 4 into 2, that is 8. So this E is equals to I plus 2n. So this is 2 plus this is 2 into number of nodes are 3. So this is 2, 3, 6 plus 2, that is 8. So here with an example I have proved it. Then one more fact we will take, that is number of external nodes are equal to internal nodes plus 1. So if there are 15 circular nodes, there are 16 square nodes. So number of external nodes will be 1 more than number of internal nodes. So this is another fact we will take. Now what is average successful time for n elements? So average successful search time for n elements is equals to total paths of all internal nodes divided by number of nodes. So we will get average path. And we know that for this node path is 2, but the number of comparisons are 1 extra. So for every node 1 extra comparison is there. So average path plus 1. So this gives average successful time in terms of paths of internal nodes. Then what is the average time taken for unsuccessful search? So average time taken for unsuccessful search for n elements is E by total number of nodes, average time. So total number of nodes are, we know that if n nodes are there, then external nodes will be n plus 1. So this is n plus 1. Average successful time, average unsuccessful time. Now there is one more fact that I have to highlight here, that is all these external nodes are at same height. So I can take the path as log n. So total how many nodes? N plus 1. So n plus 1 into log n. So approximately E is equal to n log n, or n plus 1 into log n plus 1 we can take, or else n log n. So how much is the time taken in unsuccessful search? This can be taken as n log n divided by n plus 1. So we can take it as approximate n plus 1 and cancel this one. So that is log n. So average unsuccessful search time is also log n. Now don't get confused that how I am dividing n by n plus 1. So that plus 1 you can ignore it, right? Approximate result we want. Directly I am cutting off n by n plus 1. See, for knowing the time complexity, we need the approximate, we need just the idea. So for that idea, we can take the approximate value. We don't have to be very accurate. So this is n plus 1. Assume that this is also n plus 1. As I said, this will be n plus 1, but we are writing n here. So n plus 1 gets cancelled. So it is log n. So average unsuccessful search time is log n. Then what about successful search time? See, from this formula we can say that E and I are related to one another. Yes. So in this formula I will replace E, because E is how much? N log n. So let us change this formula. So here I will do workout. Average successful for n is equals to 1 plus I by n. E is equals to I plus 2n. So I is equals to E minus 2n. So this can be written as 1 plus E minus 2n by n. This can be written as 1 plus E by n minus 2. Now E, what E is? So already we know the answer, that is n log n. So this can be taken as 1 plus n log n by n minus 2. So this gives cancel. So this is approximately log n. So average successful search time is also log n. In this video we'll look at these operations, that is get operation, set operation, finding maximum of all the elements and the minimum, that is smallest element in a list. Then we will find out how to find the total, all sum of all the elements, and also average. So let us look at these one by one. Now the first one is get operation. This is a very simple operation. Get means we want to know an element at a particular index. Suppose I want to know what is there at index 9. So the element is 33. So get the element from that index. Now only one thing we have to take care is whether the index given is valid or not. Like length of a list is, maximum index is 14. So total 15 elements are there. So we should not give any index beyond that 14. So it should not be greater than or equal to length. And even it should not be less than 0. So the first thing what we can check is if index is greater than or equal to 0 and index is less than length, then this is a valid index. This index checking we may require at many places to know whether the index is valid or not. This is how we can check it. So this is the condition for valid index. If this condition is true, then the index is valid. If it is valid, just we have to get the element at that particular index. So we can just return the element from an array at given index. That's all. So I have just written a pseudocode. It's not a complete function or something. When I write the program, that time I will show a complete function. So what is the time taken by this one? Just checking a condition and getting an element. So there are only two steps, so the time is constant. So that's all about get. Now let us look at set method. So the code will be similar to get, so I'll just change the name of this method. Second one, that is set. This method is to replace a value at a particular index. Suppose I want to replace a value at index 6. So whatever the value is, I want to just replace with this new value. So set replacing a value or overwriting a value. So for setting a value at a given index, again I should check whether the index is valid or not. If it is valid, then I should change that index location with the element x. So that's all. Now get method was for reading the value, set method is for writing the value depending on a given index. So the time taken by this is also constant. Now let us move to the next method, that is finding maximum. So for that I will change the list because this is a sorted list, so I'll take some other list. Now let us look at max operation, that is finding the maximum out of these elements. So I have a list of size 10. So the size is 10 and also I have all 10 elements present there. So the length is also 10. So from this list, if you check, the largest number is, here I have 15 is the largest number. So this means unless I check the entire list, I cannot say which is the maximum element. For finding a maximum element in an unsorted list, I have to check the entire list. If the list is already sorted, then last element is a maximum element. So for unsorted list, I have to check all. So let us see how I can check it. So for that, I will take one variable called max, and in that I will store the first element, that is a of 0. So this element I will keep it there. So max is now first element, that is 8. Now go on comparing this with all the rest of the elements, and if any larger element is found, then replace this one. So let us do it. 3, is it greater than this one? No. 9, is it greater than this one? Yes. Modify this to 9. Then 15, is it greater than 9? Yes, we got still greater than this. Then 6, is it greater? No. 10, it's not greater. 7, it's not greater. 2, it's not greater. 12, it's not greater than 15. 4, is not greater than 15. So the remaining one there is the largest element. So this is simple. And how much time it has taken for doing this? If you observe the work I have done, I have gone through all the elements once. So the time is order of n. Now the same thing I will write it as a code which will find out the maximum. So I have to traverse from first element onwards till the last element. So I can scan through all these elements or traverse all these elements by using a loop. So for I assign from 1 onwards, because already 0th element we have taken in max, then I is less than length and I plus plus. Now what I have to do every time? As I is starting from here, I should check that whether that a of I is greater than the maximum, that is this maximum. If a of I is greater than max, if any element is greater than that max, then copy that element in max. So inside max, copy that element a of I. That's all. So at the end of this loop, we will be having the largest element in the max. If you want, you can return this one, return max. So function we will see afterwards. Now let us see the analysis. See, inside the code also, I will write down here, this statement takes 1 unit of time, this statement takes 1 unit of time, and this conditional statement is inside the loop. So how many times it will execute? It depends on number of times the loop will execute. Loop will execute from 1 to last element. So just one element less. So almost n minus 1 element. So this will be executed for n minus 1 times. Then the loop itself will execute for n times. One extra. Why one extra? Because this condition will be checked for n times. So for n minus time the condition will be true, and one more time the condition fail, that is I becomes equal to length, so it will stop. So that termination condition also. So this is n minus 1, and this may execute always, may not execute always. So finally this is how much? 2n, this plus finally this is how much? 2n, and 1 gets cancelled, so plus 1. So the time function for this one is f of n is equals to 2n plus 1, which is of degree 1, so it is order of n. That's all. So from the code, if you want to do analysis, you can assume every statement takes 1 unit of time and find out how many times a statement is repeating. Then you can come up with some formula. From the formula, you can write on the degree, and that is order of n. Otherwise, if you know how you are working on this one to get the answer, based on the working also you can tell the time. So basically you should tell the time complexity based on the working. That's more better. Now next operation is finding minimum. So it is just similar to maximum. So what I have to do is, this method is minimum, and first element I should call it as minimum. So this 8 should be as minimum, and I should go on checking if any number that is smaller than that is found, then replace it. 3 is smaller, replace it. 9 is not smaller than 3, 15 not smaller, 6 not smaller, 10 not smaller, 7 not smaller, 2 is smaller, 12 is not smaller, 4 is not smaller. So finally you got the answer. So instead of checking for greater than max, then check it for less than min. And if so, modify min. This is min. And the result is also min. So the code is similar. The procedure is similar. Just instead of max, we are finding min. So the time complexity is also same. Analysis is also same. We have to scan through all the elements. That is n is the time. Now let us look at finding sum of all the elements. For finding the total of all the elements, I should traverse through all the elements and go on adding them to some variable, that is total. So for example, I will have one variable, let us say total, and whose value is 0 initially. Then go to a of 0 and add to this one 8. Then go to a of 1 and add to this one. Then go to a of 2, then add to this. So every time I should add a value to that total. So traversing through all the elements. So I need a variable that is total. That should be initially 0. I should scan through all the elements. So for I assign 0, I is less than length, then I plus plus. Then inside total, I should every time add a of I. That's it. Then return total. Now next is analysis, how much time it takes. We are scanning through all the elements one by one and we are going on adding them to total. So for all elements it's n. Total elements are n, so the time is order of n. Otherwise from the code, if you see, this statement is simple statement, constant time. This is constant time, and this will repeat for how many times? It is going from 0 to length, so n times, n elements are there. So we assume length elements, we have length elements equal to length, but let us say n. We usually write the time complexity in terms of n. Then I starts from 0, I reach till length, then it will stop. So up to length minus 1 it works, and for length also it will check the condition and stop. So this is plus 1. So as actually inside the for loop, this will execute only for one time, this will execute for n time, and this will execute for n plus 1 time. So that n plus 1 we are writing here. So it means we are ignoring these two. Yes, we are concerned about this condition, so we have written that condition. Then total how much? 2n plus 3, so 2n plus 3. So the time function is f of n is equals to 2n plus 3. Degree of this is 1, so it is order of n power 1, that is n. So this is a simple task for adding. Now the same task we can also write it recursively. Let us look at a recursive definition for finding the sum of elements in an array. Suppose the function name is sum and it takes array and number of elements n. This n is length minus 1. So here the array starts from 0 onwards, so the last index is 9. If the array starts from 1, then last will be 10, so we can say number of elements. Now this is the last index. This is an array and this is the last index. So let us say this is number of elements. Then what is sum of all elements in an array? Sum of all the elements in an array can be recursively defined as sum of n minus 1 elements. So for n element, sum of n minus 1 elements plus nth element. This is how we can define it recursively. For n greater than or equal to 0. When n is less than 0, then it is 0. Means less than 0 means minus 1, minus 2, if anything you give, then that is 0. So this is the recursive definition. For this recursive definition, I will write down a function. Int sum a and n. This is pseudocode. I am not writing a C or C++ function. Then if n is less than 0, return 0. This one. Then this one. Else return sum of a comma n minus 1 plus a of n. That's all. This sum function must be called by passing sum array a and length minus 1. That is the last index of an element, 9. This should be called like this. Call should be like this. So if you want to know the time taken by this one, so this will be calling itself. How many times? It depends on the number of elements. So time is order of n. It is calling itself only one time for all the elements. It's order of n. And recursion uses a stack. So the size of the stack will be number of elements. So recursive calls will be piling up one above another depending on the number of elements. They start from last index towards the first index 0. So that's all about sum. Now let us look at average. Average is nothing but sum of all the elements divided by number of elements. So already we have seen a method for sum, for finding sum. Now let us just change it to average. So the next operation is average. So for average we have to find the total. So this total will be getting the total number of elements, then simply return total divided by number of elements. That's all. This will give the average. Once you have a sum, then the final operation is total divided by number of elements. So these were the simple operations on an array. Now in the coming videos, we'll look at more operations on an array. In this video, we will write all those small functions like get, set, finding maximum and minimum, finding sum of all the elements, and also calculating average. So let us start with the first function, that is get. It will take the index and returns the element. So the function return type should be integer type because our array is integer, then it should take a index. But along with the index, it should also take an array. So the first parameter is struct array and it should be called by value because it's not going to modify a array. Now this is a simple function. If the index is valid, then we should return the element at that particular index. So first check whether the index given is valid or not. So if index is greater than or equal to 0 and if index is less than array's length, then it is a valid index. If yes, then simply return array of a of index, whatever the index is given. Otherwise, return it's an invalid index, so we can return a value that is -1. So this is a simple get function. Now I will also write down set function and we will try all of them inside main function. Set function will change the value at a given index, so it needs array itself, that is by address and the index and the new value that we want to change. So it will set the value at a given index. So before setting, first of all, check whether the index given is valid or not. So same thing, whether index is valid or not. Index is greater than or equal to 0 and index should be less than ARR's length, array's length, then it is valid. If it is valid, then in an array, we will change the value at a given index to new value x. That's all. This is a set function. Now let us write a function for finding maximum element, max. It should take a array structure and again it is called by value is sufficient. Then here I should have one variable for finding maximum. So max assign. First a of 0 value we will assign. So first value we will take it. Then also we need a variable I for running the for loop. So for I assign 1 onwards, I is less than a's length, and if a of I value is greater than max, then we will change max to a of I. So let us enclose this inside a bracket. At the end, we will return whatever the max value that we got. So this is the function for finding maximum. Now let us write a function for finding minimum. So I will copy this function and I will simply modify this one to make a function for finding minimum. Change the name to min and variable name also I will change it as min. Then if a of I is less than min, then change min to a of I and return min. So I have modified the function for finding min. So I wrote get and set functions as well as max and min. Now let us write a function for finding the sum of all the elements. Sum, it should take a array structure so it's going to be a very simple function and I need a variable I for running for loop. For I assign 0, I is less than ARR's length and I plus plus every time, and in this s variable we will add a of I values. So that's all, whatever the values are they will be added. Then we will return s. The result is in variable s. So this is a function for sum, finding sum. Then at last we need a function for finding average. So I will take float avg, which takes array arr I don't have to add all the elements. Already I have a function for finding sum. So let us call that function sum by passing array and divided by arr dot length. This will give the average. And this value should be of type float. So I will make it as float, typecast it as float. So average function becomes simple. Now let us try all these functions and see. So the functions which directly return the result, I will use printf. So first function I will call is get %d slash n, and here I will call a function get by passing array and the index is 2. So at index 2 value 4 is present, so it should return 4. Yes, result is 4. I will send the index 0, the value should be 2. Yes, value is 2. I'll give the index 9. Index is not there, so it should return -1. Yes, it has returned -1. So perfect, it's working perfect. So I will remove this. Next, let us try a set function. I will call set function by passing address of a array and index is 0. At that 0th index, I want to write a value 15. So this 2 should be changed to 15. This should be changed to 15. Let us run it. Anyway, afterwards we are displaying all the elements, so you can see that the elements are changed. So the first element was 2, now it has become 15. Yes, it is changing the value. So it's not inserting an element, it is just changing an element at a given index, replacing an element. Now let us call max function. So I will directly print the result %d /n max function. I will pass array. And here inside the array I will change one element to 14. So I should get maximum element as 14. Let us run the program. Yes, maximum element is 14. I'll make this as 25. Your maximum element is 25. Now I'll just change this function to min and let us see what is the minimum value. I will get the value as 2. Minimum value is 2. Yes, result is 2. I'll change the value to 23. So now the minimum value is 3. So I should get the result 3. Yes, result is 3. Now I will change this function to sum. Total sum of all the elements is 71. So if you add them, you may get 71. Then average for this array. See, it should be a float type. So I will change this to float. See, the average is 14.2. Perfect. So that's all. We have implemented all the functions. So that's all in this video. Yeah, in this video we'll talk about these operations, that is reversing a list, that is array, left shifting of elements, left rotation of elements, and this right shift and right rotation are similar to these. So I'll be discussing these operations. Let us start with reverse. For reversing an array, we have two methods. Let us look at the first method. So in first method, we will take an auxiliary array, the extra array. So we'll take one array, let us call it as B. In this array, we will copy all those elements from the actual original array and we will copy them in reverse. So from last element we'll copy. So the first element that we'll copy here will be 4. 4 is copied here. 12 is copied. Then 2 is copied here. Then 7 is copied. Then 10. So in this way, we will reverse copy all the elements. So the elements are reverse copied. Then, now we will copy these elements back into the original array. So corresponding elements, same location elements will be copying. So this becomes 4, then this becomes 12, and this becomes 2. So we'll replace the elements in a original array. So this is first method. In first method, we require an extra array. How much time it is taking for reversing the elements? So reverse copying from A to B. So from A to B, when you copy the elements, the number of elements are n. Then again you have to copy the elements from B to A. So B to A, again there are n elements. So total 2n. So it is order of n. So the time taken is order of n. Now let us write down the code for reversing the elements using auxiliary array B. We have to copy the elements from A, that is from last index, in B starting from first index. So we will take two integer index pointers. I starts from there and J starts from here. I will be decreasing and J will be increasing. So this can be done using a loop. I starts from last index is length minus 1. This is length minus 1. And also we need J, that is J assigned 0. So we'll be doing two initialization, then semicolon. So we can have two initializations in for loop separated by comma. Then comes semicolon. How long we should do this? Until I reaches 0. So beyond this one, we should stop. So I greater than or equal to 0. So when it becomes less than 0, it should stop. Then every time I should be decrementing, okay, comma, then j should be incrementing, j plus plus. Then while scanning through this array from back side and this from front side, we have to copy the elements into B at a location j from A from location I. This part is reverse copying the elements. Then after doing this, we have to copy the elements from B to A directly. So for this, we can start from here I, that same I can be used here also. 0, 0, then 1, 1, then 2, 2. So 0 is copied in 0, 1 is copied in 1 and so on. So again one more for loop for I assign 0, I is less than length. We have to go up to the last element, then I plus plus. In this for loop, we can copy the elements from B to A. So elements are copied in A from B. This portion is reverse copying, then copying the elements from B to A. Now from the code, if I see, then this statement is executing for n times for n elements, and this we know well that the condition part, this one, will be one extra, so this will n plus 1. We are not concerned about this one. We are concerned about the actual work done. Then this statement is also n. See, these loops are not inside one another. They are after one another. So its time is separate, its time is separate. So it is 2n. So the time is order of n. Time is order of n. So this is one method of reversing. Now second method I will show you. In second method, we can scan from two ends of an array and interchange the elements, swap the elements. Like first element is swapped with the last element. We will swap these two elements, interchange them. Then these two elements are swapped, 3 with 12 and 9 with 2, then 15 with 7, then 6 with 10. We need two indices, I from here and j from here, then interchange the elements. So copy 4 here and copy 8 here. Then decrement I and decrement j. Then interchange the elements. So 12 here and 3 here. So in this way, if we continue, rest of the elements will also be interchanged. Like similarly, if we continue, we can interchange rest of the elements. So when we should stop? When I and j has came on the same place, or I became greater than j, we should stop. So in this way, we can reverse the entire array. So how much time it is taking? We have to scan through all the elements. How many times? Just one time. So time is how much? Order of n. We are swapping total n elements. We are accessing total n elements. Now for the same thing, I will write down the code and show you for reversing. We want I starting from 0 and j starting from length minus 1. Then this can be done using for loop. And how long we should continue? As long as I is less than j. When I becomes greater than j, stop. Elements are over. Then I plus plus j minus minus. What we have to do each time? Interchange the elements, swap the elements. So for swapping, we take some temporary variable and in that store a of I. Then in a of I, store a of j. And in a of j, store temp. That's all. This is the code for reversing array. So we don't need an auxiliary array for this one. So the time is order of n. Now next, let us look at left shift and then left rotation. Let us look at left shift operation. I have taken a small size array of size 5 and I have 5 elements in that one. Now what does it mean by left shift? We want to shift all the elements on the left hand side. Let us see. So from which element we should start? From this element, first element. If I shift this 6, There is no space here. 6 will go out. Okay, let it go out, no problem. Then 3 will come here and 8 will come here. Then 5 comes here and 9 comes here. Then this place is free, so we can put 0 there. So this is left shifting of elements. We will lose one element in this one. Yes. So it means if I have to shift right, then I should start from here. We will lose the last element and all the elements will move one step forward and we get free space here and it is 0. So just the direction is different, left and right shift. So just the direction is different in left shift and right shift. This is shift operation. Then what is rotation? The deleted element, the first element that you got, you copy it in the last location. It means that 6 has not removed, but it came here. So it is rotation. That's all. So shifting means just moving them. How many spaces you want, you can move. Usually we move by one place. Then rotation means the deleted element is copied at the last. This is called as rotation. How much time it has taken? We have moved an element, so the time is order of n. Shifting takes order of n time. And if you have to rotate, you can keep hold of the first element and you can copy at the last. So this is called as left shift and left rotation. Now what is the use actually? So for explaining the use, I'll show you. Now usually on display boards, LED display boards, we find that the advertisements are scrolled on the display board, that is LED board. For example, this word welcome is there displayed on LED board. So this can be constantly displayed like this. Assume it is LED board only, but actually it's an array. Now we want to show it as moving, scrolling. So what we have to do, this should move this side. So remove W, move E here, move L here, and C, O, M, E, and blank space here, that blank space here, that blank space here. At the end, add a blank. So W is gone. Now if I repeat again, this all letters will move shift on this side and E will be gone, then L will be gone. So it looks like as if this word welcome is going away. So it's scrolling. Now followed by that, you can start adding some other letters then. So the advertisements will be flowing from left to right. The advertisements will be flowing from right to left on the display board. So the advertisements will be moving right to left on the display board. So with the left shifting, we can show them as scrolling advertisements. If you want this to work just like this welcome word is going around and again coming back, it's like rotation. It's like rotation. Then for that, this deleted letter, you can show it here. So now this E will be deleted and added there. So that welcome will be coming again here and it is fading away from this side. Then again it will start from there. So this is the logic used for LED display ports. So this logic is common in electronics. So in computer science also this technique is taught as left rotate or right rotate, left shift or right shift. So that's all about the basic operations we have seen upon an array. So that's all about these operations. In this video, we'll look at operations upon array. That is, first I will write on a function for reversing contents of an array. Reverse, it should take an array and it should take by address. So it's pointer ARR. Then for reversing, I have discussed two methods. So first method I will follow, I'll take one auxiliary array. So for that, I will take a pointer B. Then I need other variables like I and j. I will declare them also. The first thing is the array B should be of size equal to array A. So I should take the size of an array A and create array B from heap. So I will create array B from heap by calling malloc function. So malloc, this should be same as length of an array. We don't need size, we need length. Length is number of elements that we are having. Then the next is size of its integer type, so it is integer. Now I have an array ready. Now let us copy all the elements from array A from right hand side to array B. So for that I will take a for loop, like I starts at array's length minus 1 and j starts at 0. Then we'll continue as long as I is greater than or equal to 0. Then I minus minus and j plus plus. Every time in B of j, copy an element from A of I. This will reverse copy all the elements of array A into array B. Then again I have to run a for loop starting from 0 and I is less than length I plus plus. I should copy all the elements from array B to array A. So A of I should be assigned with B of I. Yes, this will reverse an array. Let us call reverse function here and then we will display an array. Reverse address of array. And next statement is display. So this function is called and this function will reverse all the contents of an array by using auxiliary array B. Let us run the program. We should get this array reverse. That is, instead of 2, 3, 4, 5, 6, we should have 6, 5, 4, 3, 2. Yes, the elements are reverse 6, 5, 4, 3, 2. So this function is working. So once again, see, I have created a auxiliary array in heap. Then I have copied all the elements from array A to array B. In array A, we started from right hand side and array B, we started from left hand side. Then copying all the elements from B array back to A array. This is one method. And one more method I have shown you. So let us write a function that is reverse to second version. Reverse to, it should take an array by address. Now in this method also I need two variables I and j. So let us take those variables. And as I said, using a for loop we can exchange the elements. So for I assign 0 and j assign array's length minus 1, that is from the last index, and we should continue as long as I is less than j, and I should increment and j should decrement. Then every time we swap the elements, so already we have written a function for swap. In the previous videos I have shown you the swap function will exchange the values. So this swap function will call from here swap A of I with A of j, and I should pass their addresses, so I should write ampersand here for addresses. So that's all. This will reverse an array. So let us call version 2 from main function. So here inside main function, let us call version 2, that is reverse 2. Run the program. Yes, it is also reversing, that is 65432. It's working. So this was about reversing an array. So that's all in this video. We have two more functions remaining, that is left shift and right left rotation. Similarly, we have right shift and right rotation. So you can try those functions by yourself. That is a student exercise. Let us look at few more operations on an array, like inserting in a sorted array. We want to insert a new value in a array which is already sorted. So we should add a new value at a sorted position. The next one is checking if an array is already sorted. Then one more, arranging all negative elements on the left side and positive elements on the right hand side. So let us check these. So these are few simple operations, but that are important operations. So let us check how to perform them. Now the first operation, I want to insert a new element 18 in this array, and this array, if you observe, it is already sorted. So in a sorted array, I want to insert a new element such that it is inserted in its sorted position. So where this 18 should come? So if you check here, it is greater than 4, greater than 8, greater than 13, greater than 16, but less than 20. 18 is less than 20. So 18 should come here. This is the place for 18. So I have to insert 18 there, but already some number is present there. So I have to shift the element and make free space for 18, then only I can insert it. So for shifting, I should start from last element. I should shift 33, then 28, and 25, then 20, then I'll get a free space, then I can insert this one. Now let us look at the exact procedure. For inserting a new element 18 in this list, I don't have to find out its position by checking these numbers. I can simply start checking this number by the last. I can simply start checking this number from the last number onwards. If those numbers are greater than this one, I can shift them. If suppose this is not 18, this is 38, so this is greater than 33, so I can simply store 38 here. But this number is smaller, so I can start shifting them. So 33 has to be shifted, and 28 has to be shifted, and 25 has to be shifted, 20 is also shifted. Then this number is 16, so 16 is smaller than 18, so the next place is 18 only. So I can insert 18 here. That's all. This is the procedure. The important thing that we have to observe here is that you no need to find the position of this element by comparing these elements, because after comparison also you have to shift them. So directly start shifting them. Now let us see the procedure how I can shift the elements and I can insert this new element. Let us call this element as x. So let us say it is 18, for example. Then I should start shifting from last. So from here I should start. So let us call that I as length minus 1. That is, length is the number of elements in the list, that is 8. So 8 minus 1, that is 7. So I starts from 7. Now repeatedly what I have to do, I have to go on shifting the elements. So I have to go on shifting the elements, so that is while loop I will do. How to shift an element is this a of I should be copied at a of I plus 1. So a of I plus 1 should contain a of I. So I have to shift. This shifting has to be done repeatedly. How long? As long as this x is smaller than that element. If this becomes greater, then I should stop. If this becomes greater or equal, I should stop. So as long as a of I is greater than x. And after shifting an element, I should also decrement I, that is decrement I. So I minus minus. So using while loop I have written the code, even I can use a for loop also, but for loop is useful when you know how many times you are going to repeat, and while loop we don't know how many times we are going to repeat this one. We have to repeat based on the condition that this element is smaller than the element, then shift it. So I have used while loop. Now once this has finished, so if this loop is executed, then it will move 33, then also 28, then 25, then 20. Then when it comes here, it will stop. I will stop here because this element, that is a of I, is not greater than 18. So this is not greater than 18, so it is false, so it will stop. So where I should insert this new element, I plus 1 place. So at a of I plus 1, I should insert element x. That's it. This is the pseudocode for inserting an element in a sorted list, and it is one of the important procedures. Now let us move to the next one, checking whether the list is already sorted or not. Let us see how to check whether a list is already sorted or not. Here as an example, already I have a sorted list with me. So the procedure for checking whether it is sorted or not is start from this one. This is smaller than this, and this is smaller than the next number. This is smaller than the next number. So every present number is smaller than the next number. then it means the list is sorted. If suppose here I have 26, then 4 is smaller than 8, 8 is smaller than 13, 13 is smaller than 26, yes, up to here is correct. 26 is smaller than 20, no, wrong. So it means the list is not sorted. So the procedure is check the current number with the next number. If it is smaller, go on continuing. And if you have reached the end of a list, so finally in the procedure, we will check the current number is smaller than the next number. If not, then it is not sorted. If we have reached at the end of a list by comparing this, means it is sorted. I will write like an algorithm. Let us see. Algorithm is sorted. I am calling the algorithm as is sorted, and it takes an array and the number of elements. Now we have to start checking from first element next, then next, so on. So until where we should continue, we should stop here, because we cannot compare 33 with any other number, right? So let us say there are 8 elements, n is 8, this is 8, so we should stop here. No, we have to stop before this one, so we should stop at -2 place. So using for loop we can do this one. So for I takes values 0, I is less than number of elements. No, usually we reach till here when we say n, but we have to stop before that, so n minus 1, I plus plus. Then in this, what we have to check for? Is there any pair of elements where the first one is greater than the second one? It means the list is not sorted. So we'll check for false condition. If a of I is greater than a of I plus 1, any number is greater than the next number, then return false, means list is not sorted. We got this condition satisfied, then we return false, means list is not sorted. And that's all, end of loop. If we have completed the whole array, complete array, and we never came across such a pair of elements, we have finished the array, means list is sorted. So from here we can say return true, that means list is sorted. So if at all anytime this condition is true, it will stop and say false. Otherwise it has reached the end, then it will return true. So in this case, it will check I with I plus 1. This is not greater, continue. This is not greater than this one, I or I plus 1. This is not greater than that one, continue. This is not greater than next one, okay, continue. This is greater than this one, yes, this is greater than this one, so return false. If suppose this is not 26, this is 16 only, now it is completely sorted, so it will check this one with this one, right? So this is not greater, then this is not greater than this one, this is not greater than this one, this is not greater than this one, this is not greater than, not greater than. So till here it will check not greater, so here it will stop, come out of the loop and say true, so your list is already sorted. So this is also useful, like before sorting the elements, to confirm if they are sorted or not, we run this procedure. So how much time this procedure is taking? It is iterating through all the list of elements, then it is taking order of n time. If the list is sorted, it will take n. If it is not sorted, then it may stop at any place. That is minimum one comparison it performs. So minimum time is constant, maximum time is order of n. Now next we will see negative numbers on one side, positive on other side. Now the next problem, we have an array or a list which is having positive as well as negative numbers. This is an example list. It is having mixed positive as well as negative number. What we want to do is, we want to bring all negative numbers on left hand side, then followed by that we should have positive numbers. So in the beginning of an array we should have all negatives, then when negatives have finished, then positive should start. So but they are mixed. So how to bring them at one place? Let us see how we can do it. So for this we can take two pointers, that is index pointers. One is I from the beginning of a list and one is j from the end of a list. So I from here and j from here. Then Using I, we look for positive numbers. If there are any positive numbers this side, let us send them there. And with j, we will find out if there are any negative numbers on this side, so let us send them here. So I will try to find positive number and j will try to find negative number. If found, they will exchange. So I will also simultaneously write down the code. I is starting from 0 and j is starting from length of a list minus 1. That is from there. Then what we have to do? Check, is it positive? If it is a positive, then we have to send it there. No, this is negative. So move next. Is it positive? Yes, we got the number. So it means I should continue incrementing until it reaches a positive number. So if it is negative, it should just move ahead. So I can write while a of I is less than 0, continue I plus plus. So when the number is negative, let I move ahead. If it is positive, it stop. So yes, we got positive. Then same way, j should be decremented until it gets a negative number. Is it negative number? No. Is it negative number? Yes, stop. So means j should decrement if the number is positive, it should stop if the number is negative. So while a of j is greater than or equal to 0, j minus minus. So if it is less than 0, it should stop. So yes, we got the numbers. Then what we should do? Interchange them. These numbers should be interchanged. So that's minus 4 is brought here and 3 is sent there. So we should swap them. So I will write on swap a of I with a of j. Now I should do the same thing. I plus plus. Is it a positive number? No. I plus plus. Is it a positive number? Yes. So this loop has finished. Then decrement j. J minus minus. Is it a negative number? No. J minus minus. Is it a negative number? Yes. So j is decremented until we got the negative number. Then interchange them. Interchange. So minus 9 comes here and 10 goes there. Now continue. I plus plus. Is it a positive number? Yes. The number is not negative, so I stops there. Then j minus minus. Is it a negative number? Yes. So when the number is negative, it stops. So then again swap them. So minus 7 comes here and 5 goes there. Then continue. I plus plus. Is it a positive number? Yes, it's a positive number. Stop. J minus minus. Is it a negative number? Yes, negative number. Stop. But now we will not interchange them because I has become greater than j means we have checked the entire list. So this swapping we will not do and we will stop the procedure. So this swapping is done if I is less than j. So this is conditional. So moving I and moving j, moving I, moving j and interchanging the element was repeating procedure. How long we have done this? As long as I is less than j, while I is less than j will continue. So this is the procedure for swapping the elements. So this is the procedure for arranging all negatives on one side and positive on other side. Now analysis, how much time it has taken? The time was spent on comparing the elements. So total how many elements were compared? N plus 2 elements were compared. We started from this with I and from there also we started with the j, and I has increased and check one more number. J has also decreased and check one more number. So total N plus 2 comparisons were there. Then swappings, it depends. If already all negatives on this side and positive that side, no swapping will be done. But the main time is spent on comparing the elements. So we can say the time is order of n. This is scanning the whole list just once. An exact number of comparisons are n plus 2 comparisons. Now analysis. What is the work done here? Comparing the element and interchanging them. Interchanging is happening if there is a conflict in the condition. Interchanging is happening only if positive is on this side or negative on that side. Otherwise, comparison is always done. So at most, how many elements are compared? All n elements are compared. So the time taken by this procedure is order of n only. Order of n. So that's all. These were few important operations that are performed on a list. So we have seen them on an array. In this video, we'll have the demonstration for inserting an element in a sorted array and checking whether an array is already sorted or not, and arranging all positives and negatives on either side of an array. Already we have discussed this topic on whiteboard. Now I will write down functions for them and I will show you. So I am using the same program which we have already used in the previous topics. So all those functions are present in the same project now, same program file. And here I have an array which is initialized with some number, and these numbers are already sorted. Now let us write a function for inserting an element in a sorted position. I will call the function name as insert sort, and it should take a array as a parameter, and it should be by reference. And next is the value that we want to insert. So for inserting an element x in a sorted position, I should start shifting the larger elements from the right hand side of an array and make a free space for x and insert it. So I will write on the code what we have already seen on whiteboard. So before insertion, first of all, I should check whether there is any free space in an array or not. So if array's length is equal to array's size, then there is no free space. So I should stop the function. So I will simply say return. Means if length is equal to size, then there is no free space. Otherwise, I can insert. So for insertion, I have to shift the element. So for that, I need a variable I, and that should be initialized with arrays length -1. Then as we have already seen that I have to go on shifting the element, so I should do it as long as while a of I is greater than x. If so, then I should shift an element at a of I plus 1. I should write down the value from a of I. And I should decrement I. And one more thing I should take care that I should not cross 0th index. So one more condition, I should be greater than or equal to 0, as well as this condition should be satisfied. If I am inserting a smallest element, then it should come at index 0. Beyond that, and below index 0, there is no valid index. So I should stop when it has reached 0, right? So if it is becoming -1, it should stop. Then after coming out of the loop at a of I plus 1, I should store the element. As we have inserted one more element, so the length of array should also be incremented. So length plus plus. So that's all. The function is ready, which can insert an element in a sorted position. So let us try it in main function. In main function already I have an array. The largest element is 15. Now let us insert an element by calling this function insert sort, and it takes address of array object, and the value that I want to insert is 20. So let us first insert 20. 20 should be inserted at the end of this array, that is after 15, because this will be a greatest number. So display should display all the values along with 20. So this display function will display all the elements. Yes. Now it is displaying 6 elements including 20. Let us change the value. I will try to insert something between 10 and 15. So I'll give the element as 12. So it should be inserted after 10. Let us see whether it works. Yes. 2, 3, 5, 10, 12 and 15. It is inserted in a sorted position. If I give the value as 4, so it should be inserted in between 3 and 5. Yes, 2, 3, 4, 5, 10, 15. If I give a value as 1, then it should be inserted before 2 because it's the smallest element. Yes, 1, 2, 3, 5, 10 and 15. It is inserted. So that's all with the insert function, inserting in a sorted array. Next, I will write a function to check if an array is sorted or not, that is sorted. So return type is integer. It will return whether array is sorted or not. So it will return true or false. So true means it will return 1, otherwise it will return 0. Is sorted. So it should take an array. So struct array arr. It should take the value by value. We don't need by address because just it has to check. It doesn't have to modify an array. Then to avoid an error here, I will write return 0. Otherwise, the compiler will show error here. As we have already seen the procedure on whiteboard, so we need to use for loop for scanning through this array. So for that, I will take I. Then for loop, I starts from 0. I should be less than array's length minus 1 because we should stop one element before as we are comparing two elements. So every time check what if a of I, if a of I is greater than a of I plus 1, then it means they are not sorted. Any two elements are such that first one is greater than the second one, then they are not sorted. So we will return false. False means 0. Otherwise, when we come out of this for loop, we will return 1. Means if return 0 was not done, we have checked the complete array and there was no such condition, that is the first element was greater than the second element. So array is already sorted. So this discussion already we have done. Now I will use that function. I will call that function here. So I will directly print the value. Printf percentile d slash n is sorted. I will pass an array. So I'm passing this array to this function to check whether it is sorted or not. We can see that this array is already sorted, so it should return 1. So printf should print the value 1. Yes, it is printing 1. I will modify this array and make it unsorted. So I will write 25 here. So 2, 3, 25, then 10. So it is not sorted. See one of the element that is greater than the next element. Let us run and see what's the output. See, output is 0. Means it says that array is not sorted. Yes, correct. So it is returning true or false. So wherever you need it, you can use it to check whether it is sorted or not sorted. Call this function. It will help you in taking decision by sending true or false, that is 0 or 1. Now the next function remaining is rearranging positive and negatives. So for that, I will write a function rearrange, and it should take a struct type array and it's going to modify an array, so it should be called by address. I'm calling the function name as rearrange. As we have already seen the procedure, so I will declare the variables I and j that we need. I should start from index 0 and j should start from index arrays length minus 1. That is the index of last element. Then using while loop, we have to iterate as long as I is less than j. Then each time increment I, so I will use do while loop here. Each time increment I as well as a decrement j, so I will use while a of I is less than 0. Means if it is negative, then increment I. And same way, I should decrement j if a of I is greater than equal to 0. J minus minus. So this procedure already I have shown you, so I'm not explaining it here. If I is less than j, then swap. So already we have a function for swap. So I will call that function swap by sending addresses of ar of a of I and array of a of j. These two elements we will interchange. So that's all. So if I have some positive and negative elements scattered in an array, Then it will arrange all negatives on the left hand side and positive on the right hand side. So I will try to write some negative numbers also. Here is minus 15 and this is minus 3. So then I will add one more number here, minus 7. So this minus 3, minus 15 and minus 7 should be on the left hand side. So let us call this function. I will remove this. Rearrange, send the address of array. Now total elements are 6, so I should modify this length also to 6. Now let us run the program and see what happens. Yes, all negatives are on one side and positive are on the right hand side. So you can see that 2 is swapped with minus 7. Then 25 is swapped with minus 15. So 25 went in a place of 15. So that's it. This is working. We have seen three different functions, that is inserting an element in a sorted position and checking whether an array is sorted or not, or rearranging the elements. Yeah, in this video we'll talk about merging, that is combining two sorted lists into a single sorted list. Merging is a binary operation. It needs more than one array so that it can combine them into a single array. Likewise, merging, there are more binary operations on an array. Quickly I will tell about them. One is append, concat, compare, copy. These are some of the binary operations on an array. Here you need more than one array. Like appending an array. Already we have an array and there is suppose free space. We want to add these elements followed by this one. That is append. Concat, that same thing, combining these two arrays is concatenation. So it may be done in third array, like all the elements of array A, then all the elements of array B followed by that. Appending means that array is updated. Concat means that may be in some other array. It's the same thing. Concat and append are same. Comparing two arrays, comparing whether they have a same set of elements or not. So one by one we have to compare the elements from two arrays. Then copying. So if you have an array of elements and there is a free array, empty array, we want to copy all these elements in this one. So this is copying. Now likewise we have merge. Now let us see what is merging. Merging can be done only on sorted list. So first array is sorted and the second array is also sorted. And we have to combine these two arrays and get a single sorted array. And for merging, we need definitely third array. We cannot combine and store only in A or only in B. We need one more array, let us say C. Now how to combine them? Before looking at the procedure, let us say the number of elements in this array are m elements and this array are n elements. So that is having m elements and this is having n elements. Now we will combine these two and store them here such that they are sorted. So for that we will take index pointers I, j and k. I start from first index of A and j starts from first index of B and k starts from here. Now what the procedure we perform is a repeating procedure. So what we have to do? Compare A of I with B of j. Whichever is smaller, copy that one here. So if A of I is smaller, copy it. If B of j is smaller, copy that one. So right now A of I is smaller, so copy this the one. Then move I to the next element and move k to the next element. Then compare A of I with B of j. Now B of j is smaller, so copy this element 4 and increment j and increment k. So what we are doing here, I will write down a pseudocode for that one. Initially I is equals to 0 and j is also 0 and k is also 0. That was initial one. Then we are comparing if A of I is smaller than B of j. If so, then in C of k we will copy A of I. and we increment k as well as I. Otherwise, in C of k plus plus, we will copy B of j plus plus. This is what we are doing. So let us continue. A of I is 8, B of j is 10, so 8 is copied here, I is moved further and k is moved further. A of I is 16, B of j 10, so 10 is copied, then j is moved further. A of I is 16, B of j is 12, so 12 is copied and j is moved further and k also moved further. A of I is 16, B of j is 22, this is 16, this is 22, so copy 16, move next, move next. A of I 20 and this is 22, so 20 is copied here. I is moved, k is moved. Now this is 25, this is 22, 22 is copied. This is 25 and this is 23, so 23 is copied. Then j plus plus, k is here. So j became 5 now, means it has gone outside the size of an array. There are total 5 elements. So j became 5 now, it means the second list B has finished. We should stop. We cannot compare now A of I with B of j. Then what to do? Definitely there are some elements left over in A. Copy them. From wherever I is, from that same place, start copying the remaining elements. Suppose I have more elements, copy all of them. And definitely at least one element will be left over. So in our example, here we got one element left. If suppose this is not 23, this is 28, then this will left over, that 25 will be copied. So in any one of the list, at least one element will be left over, so we have to copy that element. So copy that 25 here. That's all. This is the merging process. Now let me complete the code. See, I was comparing and copying every time. Repeatedly I was doing. So this was happening while I is less than m and j is less than n. Compare and copy. But we have stopped when j became equal to n. So when it is less than n, we were continuing. When it is equal to n, we stop. We have to stop either if the first list ends or second list ends. Means I becomes equal to m or j becomes equal to n, we have to stop. Okay, we have stopped. Then what we have to do? Copy the remaining elements. If in the first list, copy the remaining. If in second list, then also copy the elements. So for that, I will write on the code here. For wherever I is, let it be there only. I less than m, I plus plus, C of k plus plus assign A of I. This will copy the remaining elements from first list. If suppose there are some remaining elements in the second list, then copy j less than n, j plus plus and C of k plus plus, copy B of j. So this is the code for merging. So at last I will copy that 25 also here and move I and k also and stop. We have combined two sorted lists into a single sorted list. And this single sorted list is having total m plus n elements. Now, analysis. What is the work done? Comparing the elements and copying the elements. Here we prefer copying of elements. So how many elements are copied? M elements from here, n elements from here are copied. So total time taken is m plus n. So it is written as theta of m plus n. See, so far I was writing order of, but this is a known one. We use a theta. We can use big O or omega or anything also, but usually theta is used. So I will explain you what is theta afterwards. So the time taken here is theta of m plus n. Total m plus n elements are copied, and this is the first time we are giving the time complexity in two variables, m and n variables. So this is a notation for merging. Wherever you see m plus n, then definitely there is merging used there. So m plus n is for merging. So that's all about merge process. In this video, we will look at a demonstration for merging two arrays. So first of all, I will create two arrays. I will directly initialize them. Struct array, I will call first one as ARR1 and I will initialize it. The list of elements are 2, 6, 10, 15 and 25. This is the first list, so there are total 5 elements. And the size of the array, I can give any size, so I will give a larger size, and the number of elements, that is length, is 5. This is the first array. Then second array, struct array ARR2. I will initialize the array first, so the elements are 3 and 4, 7, 18 and 20. Now the size I have to give size, it can be greater than or equal to 5 because I have only 5 elements. So let us give the size as 10 and then number of elements are 5. So I am taking same number of elements in both the arrays. Then the third array I want. So for that I want a function merge to create third array. So for that I will take a pointer ARR3. I will not create an array. Now these three variables, it is giving a warning that these three variables are not in use. Yes, we have not yet used them. This is the same program or the project that we have been using. So inside this I will write a function for merge. Merge should take two arrays. Merge should take two arrays. It should take by address. So first one is ARR1. I'll give the same name, struct array, and second one is ARR2. Then what are the things we require in this function? We need I and j that will help us tracing array1 and array2. Then I need third array for storing the merge result, and its array size should be 10. I will create an array from heap. So for that I will take a pointer star ARR3. Then here I will say struct array pointer malloc size of struct array. So this object will be created in heap so that I can return it and I can use it inside main function. The merge result, I should be able to use it in main function. So that's why I'm creating this on heap. Now we'll write on the procedure that we have already discussed on whiteboard. While I is less than ARR1's length and j is less than ARR2's length, that second array's length. As long as I is less than first length and j is less than second length, we have to compare the elements. Now we have to compare and copy the elements. So I will initialize these variables. So I need k also. So let us initialize these three variables, I assign and j assign, k assign 0. All these three are initialized with 0. Now here I will compare and copy the elements. If array1's element is less than array2's element, then array3's element should be set to array1's element. And this I and k both should increment I as well as k. Else in array 3 we should copy the elements of second array. K plus plus should be equal to assigned with ARR2's element. That's it. So this loop will copy all the elements by comparing them one by one, and it will stop when one of the array has finished. Now I have to copy the remaining elements from any one of the array. So I should start from wherever I is. So I is for first array length, then I plus plus, then in third array I should copy the elements from first array. And similarly, I will copy and paste this one. I will copy and paste this one, and this should be for j. Instead of typing again, I will make it for j. This j is less than array 2's length and j plus plus, and here j should be copied in k, and this should come from array 2. That's all. This will merge both the arrays and store the result in array 3. Now for array 3, I should set its length. Length should be array 1's length plus array 2's length. This I should set. And array 3's size is not set. I should set the size also to 10. That's all. Now as this array 3 is created in heap, I can return this to the main function. So I can say return array 3. And here the function should have the return type as struct array pointer. Yes, the function is little lengthy, but it is ready for merging. This is the function for merging. Now from inside main function, I will call merge by passing address of first array and address of second array, and the result I will take it in array 3. Then whatever the result I got, I will display that. So let us call the function display, and it takes call by value, so I should send star arr3. That's all. Now these elements should be merged, and I should get all sorted elements in array 3. 2, 3, 4, 6, 7, 10, 15, 18, 20 and 25. Yes, perfect. It's working perfect. So merge function is merging all the elements. So this merge function we may be using at various places. So that's all we have seen merge function. That's all in this video. Now let us look at set operations. If the sets are stored in an array, then how we can perform those operations. So the operations are performing union of two sets, intersection and difference, set membership. So here I have example of two sets that are stored in arrays A and B. Some 5 elements I have taken. And I have taken one more example here. The difference is these elements are not sorted, but these are already sorted. So let us see how we can perform these operations if the elements are not sorted and if they are sorted. So let us look at union operation. Let us see how to perform union. So for that I will say this is having m elements and this is having n elements. Now what is the procedure? Copy all the elements of first array 3, 5, 10, 4, 6. So the first set is copied. How much time it has taken? M. Then I should copy second set 12. Shall I copy it or not? See, I cannot blindly copy second set. If already it is present here, I should not copy it. 12. Search for it. Is it there? No, not there. Then copy it. 12. 4. Search for it. Is it there? Yeah, it's there. So don't copy it. Then 7. Search for it. Is it there? No, not there. So copy it. So every element I am searching here. Searching takes how much time? Depends on the number of elements present here. So already I have copied those elements here. So m elements are there. So it is taking order of m. So it is taking m time for searching. So let us continue. 2, is it there? Not there. So copy it. 5, it's there. So don't copy it. So 4 and 5 were already present here. So those are not copied. So every element we have to search. So how much time it is taking? M is the time taken for searching. No doubt the elements are increasing afterward, but let us say M is the time for searching. How many times we have done this one? For n times. So into n. So the total time is M is for copying first array elements. Then second one is copying second array elements, that is second set's element, but every element has to be compared. So this is M plus M into n. So this is the highest degree, M into n. So we will not use two variables, we will take single variable only. So let us call this as n plus n into n, that is n plus n square. So this is order of n square time. So for performing union, it has taken n square time. This is very slow. This is quadratic, time consuming. Now let us see, if we have sorted elements in the sets, then how we can perform union on those sets. Let us see. Let us say these are m elements and these are n elements and these are sorted. I have to combine them and store them in C without duplicates, that is union. So I can use merge procedure here. We have already learned what is merging. That same merging procedure we will perform. So what we will do is, let us say here is I and here is j and here is k. Compare A of I with B of j. B of j is small. Copy this 2. Then move j and move k. A of I with B of j. So A of A is small. So 3 copied. Then move this one. A of I and B of j both are same. So copy that 4 and move I also and j also, and k is here. So if they are equal to this one. Now again A of I with B of j, both are equal. Copy it once, move I also and j also, and k is here. Compare A of I with B of j. 6 is small, so copy this one, move I. A of I with B of j. 7 is small, 7 is copied, move j. A of I with B of j, 10 is small, copy 10. Then leftover is 12, so copy that 12. So this was merging. Only a slight change is that if they are same, copy only once and move both I and j. So it is merge process, so it is m plus n. We can say this is theta of m plus n. If you want to represent this in a single variable, then you can say theta of n plus n. This is nothing but 2n. So 2 is coefficient. So leave it n. So this is order of n. So if the list are not sorted, it's n square. If they are sorted, then it's n. So that's all. This is about union. Now next is intersection and difference. So we don't have to learn much there. Now already we know how to perform union. They are similar with some changes in them. Now let us look at intersection. Intersection of two sets. We have to take common elements of A and B and store them in C. So the procedure is, start checking the elements of array A. Copy them in C. But before copying, check if this element is already present there. It's not there. So move to the next element. Is it present here? Yes, it is present. Copy that 5. So I am checking this element in this one. So I am searching for that element here. How much time it takes to search for any element here? Like 5 I am searching. So it's take n time. Then search for 10 also. Search for 4 also. How much time it takes for all n m elements? So this is m into n or n into m. Then check next. 10, is it there? It's not there. Move to next. 4, is it there? Yes, it's there. Copy 4. Then move to next. 6, is it there? It's not there. Don't copy it. So while copying the elements from array A into C, check if they are also present in B or not. That's it. So every element I have to search here in n elements, and I have to search all m elements. So m into n. So if we write it in single variable, then it is n into n and it is order of n square. So this is also time consuming. Now let us see how to perform intersection if they are already sorted. So here also we use the same procedure of merging. So for merging, let us start indices from 0 of each list, that is I, j, k. And in merging, we check which is smaller, A of I or B of j, which is smaller. This is smaller. Don't copy it. We don't want that element. Move next. Then compare A of I with B of j. That's smaller. Don't copy it. Move next. Now compare A of I with B of j. Both are equal. We want that element. So copy that element 4, move I as well as move j and move k. This is not merging but similar to merging. So we are using that procedure. Then compare A of I with B of j. They are same. So copy that 5, move I and move j and move k. Then compare A of I with B of j. 6 is smaller. Move next. Don't copy it. Then B of j is smaller. Move next. Then A of I is smaller. Move next. Finished. That's all. Stop. Don't have to copy anything. So the procedure is same as merge procedure and the time is theta of m plus n. In a single variable, it is n. So in union, if you remember, we were copying all the elements and duplicates one time, but in intersection, we are copying only duplicates. Now the next operation is finding difference. Next operation is a set difference, that is difference operation. We have two sets, then we say A minus B, that is subtraction of two sets. A minus B means we want all those elements of A which are not there in B. So subtract the common elements between A and B and take only those elements which are only in A, not in B at all. So this is a difference operation. How to get those elements? So what are those elements? Let us see. See, 3 is not present in B, 3 is in the result, 5 is there, don't take it, 10 is not there, take it, 4 is there, don't take it, 6. So 3, 10 and 6, these are the three elements that comes after A minus B. So how to perform this operation? So we have to copy all the elements of A, but copying every element, check is it present here? 3 is not present, copy it. 5 is present here, don't take it. 10, it's not there, take it. 4, it's there, don't take it. 6 is not there, take it. So every element of A is compared with all the elements of B, and if it is not there, then we are copying it. So we are searching here. So m elements are copied and every time they are searched in n element. So this is m into n. So in single variable, this is n into n and this is n square. So the time is n square. Now how it has to be done in sorted sets, if the lists are sorted, then how to do that, let us see. We can again use the merge procedure. So we will take indices I, j and k. Now we will run the process similar to merging. Let us start. A of I, B of j, this is small. So we don't want the element from B at all. Move ahead. Compare A of I with B of j. 3 is small, copy it. Then move ahead. They are same, don't copy anything, just move ahead. They are same, don't copy anything, just move ahead. That's small, copy it. Move ahead. Then this is small, move ahead. Then that is small, copy it, move ahead. First list has finished, so stop. We are not copying from B, we are copying only from A. And we are running the same procedure just like merge. So the time is m plus n theta, and in single variable it is n. And there is one more last operation, set membership operation, that is to know whether an element belongs to a set or not. Like 10 belongs to set A or not. So search and find out, yes, it's there. So set membership is same as searching only. So that's all we have learned about set operations. Mostly they are binary operations. So that's all about operations on an array, that is ADT topic. So that's all. We have seen various operations on an array, that is on a single array, as well as binary operations, that is more than one array also we have seen. In this video, I will show you union, intersection, and difference operations upon set of elements. On whiteboard, I have discussed two methods. One method for unsorted array and one method was for sorted array. And sorted array method was using merge. So I will show you a method using merge, that is for sorted array. So this is the program already we have written for merging, and it's a single project that I am using for all the functions or the operations on an array. This is the same project what I am using it for operations upon an array. So in the same project, I will use that merge function and I will convert into union, intersection and difference. So for that, first of all, let me take some set of elements. First set is having 2, 6, 10, 15 and 25. So in the second set, I will write down few common values like 6 is common and 15 is common. When we perform union, we should not have duplicates. So for performing union, I can take the help of merge function. I will copy that same merge function and I will change it for union. So here I will copy that function and I will call it as union. So union for sorted array is same as merging. In merge process, this is a loop where it will compare the elements of array 1 and array 2 and copy the elements in third array in the sorted order. So the logic for performing union will also be same, only the difference is that if the elements are same, then we should take only one copy and increment in both the arrays. So I will modify this. See, this is if array 1 element is smaller than else. So I will modify this and here I will write on if array 2's element is smaller, that is a of j is smaller than array 1 of a of I, then copy this. Otherwise means if both are equal. If both are equal, then in array 3 of a of k plus plus, copy any one of the elements. So I will copy an element from array 1 and I plus plus, and followed by this I will also perform j plus plus, means I should increment both. So this should be inside the bracket because I have more than one statement inside else block. Yes. See, this is if array 1's element is smaller, and the second one is if array 2's element is smaller, then third one if both are equal, then copy any one element and increment both I and j. And one more thing I have to modify here is that length of third array will not be equal to sum of lengths of array 1 and array 2, but I can take it as k, whatever the value of k is, that is going to be the length of third array. Then size is 10. So that's it. Let us try this. Instead of so that's it. This has become a function for union of sorted arrays if the arrays are sorted. I will change the function name. I will call it as union. Now let us run the program. I should get a union of these two arrays, so where there are no duplicates. So the elements that I expect are 2, 3, 6, 7, 10, 15, 20 and 25. So 6 and 15 are repeating, so they should be taken only one time. Let us run. Yes, 2, 3, 6, 7, 10, 15, 20 and 25. So there are no duplicates in this one. So this is working perfect. So this was for union. Then I will copy this function for union. I will make changes and I will make it as function for intersection. Here I will paste it. Then first of all, I will change the function name to intersection. Function name is intersection. So in your compiler, if you are unable to give long names, you can take short name. In intersection, we should copy an element only if they are equal. So I should not copy these elements. So instead of copying an element, I should simply say I plus plus, just move to the next element, don't copy it. And in this case, if second element is smaller, then I should just increment j if the second array element is a smaller. Then else means both are equal. See, this one, array 1 element is smaller, this one is for array 2 element is smaller. If both are equal, then copy any one of the element either from array 1 or array 2 and increment all I, j and k. And here we should not copy the remaining elements. We should take only the common elements. So remove the code for remaining elements. Two for loops were for copying the remaining elements either from array 1 or array 2. That's all. Copying only common elements. So this condition is, if I write the condition, then array 1's element a of I is equal to array 2's a of j. I have written the condition also. Otherwise, this just else is sufficient there. Now the code is readable. You can read everything condition here. That is, if this is smaller, increase I. If this is smaller, then increase j. If both are equal, then copy them. So if we come back to the main function, I have two arrays and the common elements are 6 and 15. So if I call a function that is intersection, then I should get the answer 6 and 15. I'm calling intersection function, then display third array. Let us run this. Yes, we got the result as 6 and 15, that is intersection of these two sets. As these two sets are sorted, so we are able to use the logic same as merge logic and we are able to find intersection. Now the third operation that I have to show you is difference, that is array 1 minus array 2 we will do. So I will copy the code of union. So I will paste it and I will modify that one for difference operation. This is for the union. So I will make it as difference function. Difference. Now in set difference, I should copy the element only from first array. So this part is okay, first array. And second array element I should not copy, simply I should increment j++. And when both the elements are equal, I should not copy the element at all. That's what the difference is. So here I should not copy any element, but I should increment I as well as j when they are equal. Both I should increment. And I should copy remaining elements only from array 1. I should not copy the remaining elements from array 2. Even if there are any remaining element in array 2, I should not copy them. That's it. So here only the elements of first array are copied. Second array elements are skipped. If both are equal, then skip both of them. So here inside the main function, if I take a difference a minus b, then 6 will not be there, 15 will not be there. I should get 2, 10 and 25. So let us call this function difference. Yes, 2, 10 and 25. This is the result I got. So that's it. These are the three functions we have seen. And there is one more function I have shown you, that is set membership operation. That is nothing but search. So either you can use linear search or binary search. Same function you can copy once again and you can change the name as a set membership function. So using merge algorithm, I have shown you three different operations like union, intersection and difference. And the first method for unsorted array, that is you have to implement those functions. So that's a student exercise. In this video, I will show you how to write a single menu driven program for all the operations upon an array. So we have seen various operations upon an array and I am using the same project. See, in this project, initially we have defined an array having the members. This is the pointer for an array and this is the size and the length of an array. See, I have changed it to a fixed size array and I have shown you all the functions. Now back again to a pointer so that we can have an array of required size. Then I have all these functions: display, append, insert, delete, swap, linear search, binary search, and recursive binary search, get, set, max, min, sum, average, reverse, and recursive reverse. Second method for reversing and inserting in a sorted array, then checking whether array is sorted or not, rearranging the elements, merge, then union, intersection, difference, all these functions we have seen. So in any application, if you require an array, you can use that one. But here I will show you a menu driven program where we can use all those functions. So let us write a menu driven program. First I will declare an array arr1. If any other variables are required, I will declare them. So first of all, I should know what is the size of an array I want, because there is a pointer and I should dynamically create an array and assign it to that pointer. So I will take it from keyboard asking what is the size. So we have already seen how to take the input from the keyboard and create an array of required size and also fill the elements. So I will finish the code for creating an array of required size. Yeah, here initially I am asking the size of an array and taking the size of an array and then creating a array inside heap and assigning it to a pointer A. Now here I will write the code for menu. Let me finish the code, then I will explain. Here I have prepared the menu with few options like insert, delete, search, and finding sum, and then displaying an array. You can add all other options like reversing an array, checking if it is sorted or not, performing union, intersection, or merging. All those operations you can provide. I'm just giving the idea how you can prepare a menu driven program, so few options are there. Then here I'm asking enter your choice. So let us say ch is a variable here, in that a choice is taken. Then using switch case, I can call the corresponding function for each options. The options are having numbered from 1 to 5. So whatever the option is given, I will call corresponding function. Here I write switch case upon ch. See case 1, first case. In the case 1, I should call insert function. So for that, I should know the value that I want to insert and the index at which I want to insert. So I will take those things from keyboard, enter an element and index. Then scanf, I should read two values, the value to be inserted. Let us take it in the value to be inserted and index. So x is for the value and index is for location where we want to insert. So and these two variables are already declared here. I have those two variables. When I have these two things, then I should call function insert by passing address of an array1 because it is called by address, then index at what I want to insert an element, then also x. That's all. Break. Likewise, I will fill rest of the cases, delete, search, sum, and display. I will finish rest of the cases, then we will continue our discussion. Switch case is ready here. This is the first case for inserting an element. Now I'll explain you the second case. For deletion, it's asking an index, then it will delete an element, then it will print the deleted element. In the third case, we want to search. Search is a key what we want to search, then call linear search function by passing key and it will return the index, and the index of that element is displayed here. Then fourth option is for displaying the sum of all the elements of an array. So I am calling sum function and directly displaying the result here. Then fifth option is display. So that's all. Sixth option is for exit. So better I will write on this entire thing inside a loop. So I will use do while loop so that this menu repeatedly appears, and this should be do while choice is less than 6. If choice is greater than 6, it should stop. See, I have options from 1 through 5. So for 6 it is exit, So 6 or greater than 6, the program should stop. Let us run the program. Yeah, first it is asking for an array size, so I'll give the array size as 10. Now there is nothing in an array. First of all, I should insert few values. So first option I will take, that is insert. The value that I want to insert is 2 and the index should be 0. I will insert one more value. The value I want to insert is 3 and the index should be 1. Let us display, I should get two values, that is 2 and 3. Yes, 2 and 3 are there in an array. I want to insert one more value. Element is 15 and index is 0. Let us display. Yes, 15 is inserted at index 0. I will insert one more element, that is 10 at index 3. Let us display the elements. Yes, I got it. Then I want to delete an element. I have taken index 0. Let us display the array. Yes, value 15 that was in the beginning at index 0, that is deleted. Let us call sum of all these elements. I should get 15. Yes, it is working perfect. So in this way you can try out all the options and you can go on inserting and deleting the elements, and you can use menu options and test whether your program is perfect. All the functions are working in coordination or not. We have seen individual functions, but this menu driven program will help you to verify whether to confirm all the functions are coordinating properly or not. That's all with this menu driven program. In this video, I will show you how to convert a C language program into a C++ program. So already we have seen all the functions perform on an array. I will use that same code and I will transform it into a C++ class. Let us go next. And this is array CPP. Project name I am giving it as array CPP. And the language I will select it as C++. Next, it's created. And this is the main function. I'll copy the complete program what we have written for C language. That same program I will copy it here and I will modify it to make it as a C++ program. So I will remove this main function. I will copy and paste that program here. Yes, I have a complete C language program we have written. I'll explain you this program first. See, we have defined this structure for an array containing a pointer for pointing on an array, dynamic array, and the size and the length. These are the data members of a structure array. Then we have written various functions on this array. All those function prototypes are available here. I have written their prototype, and followed by that these functions definitions are available. See, all these functions we have written, and finally I have written a main function at the end, that is menu driven main function I have written. Here is a main function. So the same program I am using it, I will modify it as a program for C++. So I will convert it into a class. So one important thing is C language programs are more related to the logic or the procedures. So already we have all these procedures. Then C++ is more related to designing or organizing the code. So the same code we will organize it using C++. So here I will start making changes. First of all, instead of struct, I will say class. This is a class array. And class array is having a pointer, that is definitely I need a pointer, and a size of an array and the length. Yes, we need all these things. And these are data members. So I should make them as private. All these are private. Then inside a class, we will have data members and the functions. And the functions, we usually make them as public. Yes, I made it public. And the first type of functions that we write is a constructor for an array. So I will write down a constructor function, that is non-parameterized constructor I will write. In this constructor, let us set the size of an array as minimum 10. So by default, the size of an array is 10. See, I don't have to use any membership operation now because this is inside a class only, so I can directly say size. And length is 0 initially because there are no elements. Then this array, I should create it dynamically. So I should say new int of size. So size already I have made it as 10. This is a non-parameterized constructor. And next, I will also write a parameterized constructor which will take the size. So I will give the variable name as sz. And I will do all these things here also. Same thing I will do here. See, instead of 10, I have to set the size as sz. That's all. This is a parameterized constructor. Then also I should have a destructor. So I will write a destructor for an array because here we are using dynamic memory. So I should delete that memory, delete A. As it is an array, I should use subscript operator. That's all. Constructors and destructors are ready. Now I should write all these functions inside this class. So simply I will include the prototype of all these functions inside the class. So I will remove this closing bracket of a class. Watch it here. This I am removing. Now these functions are inside the class now. All these are class members. Then at the end here, end of all these functions, I'll give a closing bracket of a class. Yes, this is a closing bracket of a class. That's it. All these functions are inside the class now. All these are members of this class. Now I have to modify these functions, bring some changes in them. So I will change all these functions one by one. First, let us see display function. It is taking an array as an object of type structure. So it doesn't have to take because it is already there inside a class array. It can directly access these members. It doesn't need any parameter. So yes, it means all these function doesn't need any parameter. Yes, this doesn't need any parameter of type structure array that we were passing. We don't have to pass it. They can directly access it. Then coming to the swap function, see this swap function, we have written it for using them inside another function. So it is not available globally. So I will make this function as private. This is a local function. This is useful only within a class and is useful for other functions. So I will make it as private. It is inside the private block now. Then linear search, I don't have to send array. I should only send a key. Then the parameter for binary search, it doesn't need an array. It needs only a key. Then get function, this doesn't need any array as an object. So all these doesn't need array as a parameter. They need other parameters like set, we need the index and the value. Finding maximum, whose maximum? The same array's maximum. It is inside this array class only. This is inside this array class. Whose maximum? This array's maximum. So we don't have to pass any parameter as an array. So all these are removed. Now coming to merge, union and intersection, they are taking two parameters, but here it should take just one parameter. Second array it should take, so I don't have to write struct for that. Remove struct, and here also return type remove struct because it's a class. For a class you don't have to write a class or struct anything there. Just a class name is sufficient. They all should take only one parameter. That is the second array. First array, it is itself. So I'll remove this first parameter. Yes, all these functions became members of a class. These are all members of a class now. So they can directly access this array. Now outside the class, I should implement all these functions. So for implementing all these functions, I should write down class name and scope resolution and the function name. This I should add it before every function. And the changes what I have done is this array object should be removed, right? Then when accessing, I should directly say length. I don't have to say arr dot. I don't have to say arr dot. That's all. This function is changed. I will change few functions. Rest of them you can do it by yourself. That is easy. Remove this array parameter because it's not taking, and scope resolution, this is belonging to a class. Then for length, don't say ARR's length, just say length, and just say size because it is inside the class itself. And here don't say ARR dot operator. We don't need anything. Then insert function doesn't need array object as parameter, and whatever the members are, it can access them directly because it's a member function now. Yes, I have modified this insert function by removing the array as parameter and directly accessing the members. I will do the same thing for rest of them also. I have modified all the functions. Now it's coming to merge function. Merge function, it's taking two parameters. So here I should remove only one parameter. Second parameter is mandatory because it's going to merge two arrays. First array is itself and the second array we have to pass it as parameter, and it need not be a call by address. Then here for creating an array, I should use new operator for creating an object. Say new array, and I will call the parameter as constructor. The merge array size should be same as length of a first array, that is this array itself, and the length of second array. This is the change. Now for accessing first array members, I don't have to use any operator, that is membership operator. For the second array, I should have membership operator. I made it by value, so it should be dot. It should not be an arrow. And for third array, it should be as it is. This I will remove. Then second array, it should be dot. Third array, it should be arrow because it's a pointer. I have taken a pointer. Then first array, I have modified it. Then this one, remove this membership. Then this is dot operator. This is also dot. Yes, so again this array should be removed, and this should be dot, and don't have to set the size. Already I have given the size. That's all. Now similarly I will modify union, intersection, and difference also. Now coming to the main function. Inside the main function, I should create an array object. So I will make it as a pointer, and when I know the size, here I will create an array object by passing size as a parameter. So in this line, I'll be creating array object arr1 assign new array, and whatever the size is given here. Then inside the main function, I will take one more variable, that is as a z for the size. Then here when taking the array size, I should take as z, and dynamically I should create an object now. Arr1 assign new array of given size. Yes, that's it. I don't have to initialize anything. Now the menu options, if you look at, then every function I should call it with arr1 dot insert. I don't have to pass this array, but it has become a member, so I should say dot. So this array parameter I should remove, and here delete I should say arr1 dot. Then linear search arr1 dot. This array parameter that was passed should be removed. Then arr1 dot sum, and array parameter I should remove. Now sum came inside array1 object, right? So this is arr1 dot display. So that's all. I have modified everything inside the program. Now you can see that this has become a C++ program. So I have also changed the printf and scanf functions and made them as scene and couts. So completely C++ code. Now let us see, are there any errors, anything I missed? I have actually changed the preferences in this Xcode option, that is show live issues. I have checked this one. Now let us go through this. Let us run the program. Yeah, program is running. It's asking for the size of an array. I'll give the size as 10. Now first option, I will select insert an element. I want to insert a 3 at index 0. Then enter the choice. Once again, I will insert an element, that is 5 at index 1. Then I will display the elements. So you can see here that 2 elements are there in a list, that is in an array, that is 3 and 5. I'll insert few more elements. Insert 9 at index 2. Then once again insert 8 at index 0. Let us display this list. See, 8 is inserted in the beginning, that is at index 0. Then we have 3, 5 and 9. Here are the elements displayed. Now let us display 5. 5 is at index 2. So I will select the option, that is delete. Option is 2. Then index, I'll give it as 2. Then let us display the list once again. Now the list is 8, 3 and 9. 5 is gone. Let me call the function sum and see the result of adding all these numbers. Yes, sum is 20. That's it. So you can take the list. So that's it. Like this, you can create a menu and try all the operations of an array. I am trying only few operations here, though I have written a lot of operations inside a C++ class. This is how we have learned how to convert a C language program into C++ program. In this video, I will show you how to write a C++ class for an array from the scratch. So already C language program we have seen, we have developed various functions. I will develop few functions here in a C++ class, so you get the idea how to write a C++ program for the same thing. Once you know how to write down the procedures, then either you can develop a C program or you can make it as a C++ program. Choice is yours. It's not difficult to develop a C++ program. It's as easy as writing a C language program. So let us see how to write a C++ program, how to write a class for array. I'll give the project name as array class and the language selected is C++. Create a project. Now the project is ready. Let us go to main function. Here is main.cpp. Yeah, here is a main function. I'll remove these panels on the left and right side. Now only a main function is here. Now let us write a class for array. I'll write a class array. A class in C++ should have data members and member functions. So what are the data members we require for an array? We need an array for storing the elements and size and length. So data members, I will make them as private. So first of all, array. For array, I will not make a fixed size array, but I will take it as a pointer so that I can dynamically create an array. The next is the size of an array that I want, and next is length, that is the number of elements that are present in an array. So if you look at these data members, these are the same data members of a structure in C program. Now we have written various functions in C program, so here also we will write them as member functions of an array class. And the member functions must be made as public, so I will make them as public. Now as this is a class, C++ class, it must have constructors and destructor. So first of all, I will write constructor and I will expand it here only. This is a non-parameterized constructor, and in this non-parameterized constructor, we should create an array of some default size and set the default size. So I will first set the size of an array as 10, and the default array I will create it of size 10. So let us make an array of size 10. Then length, there are no elements initially, then it is a 0. Then next I will write down a parameterized constructor so that I should be able to create an array of desired size. So I will take the parameter as sz. Then first I will set the size as sz. Then also I will set the length 0 because there are no elements so far. Then I will create an array dynamically of size size. Already size sz is set in the size, so whatever the size is passed, that size array will be created. This is about a constructor. Then we should also have a destructor. Destructor should release resources. So any resource we are acquiring here, yes, we are dynamically creating an array in heap. So this array should be released. So let us write a destructor. Destructor should have a same name as class name, just prefix with tilde symbol. So here I will delete a dynamically created array, that is A. As it is an array, I should use subscript symbol. Now I will write few functions here. The functions already we have seen, like insert, delete, display, search, so on. So I will write down only 3 functions: insert, delete and display. So first of all, let us write a function for display. This is a display function. Now, if you remember, in C language program, we were passing array as a parameter to this function, but we don't have to do it here because this function is a part of this array class. It can access these members directly. Yes. So this doesn't require any parameter at all. The next is insert function. As per the C language, we have seen that insert function was taking 3 parameters: array and the index and the element. So here I will just take index and element. Then delete function will take just index and it will delete the element from that index and return it. So that's all, 3 functions I have written. And you can continue writing all other functions like search, reverse, merge, finding maximum, finding minimum, setting an element, getting an element. All the functions that you have seen you can implement similarly. Now the functions prototype looks similar to C language functions except that they are not taking parameter as struct array. Except everything will be same. So the procedures written inside these functions will also be same. So now I will implement these functions outside the class using scope resolution operator. So the first function that I am going to implement is display function. So this is a class name array. Then this is a display. And this function is for display purpose. So I can directly declare a variable here in C++ for int I assign 0, I is less than length. So where is length? This length which is directly declared inside the class. So this length I can directly access. I is less than length, then I++. Then I should use cout for displaying the elements, that is a of I, all the elements I should display, and I want spaces in between the elements, that's all. Then at the end, I should also have endl for the new line. Now here I am getting a error, that is cout is an undefined identifier. So here actually I should use namespaces using namespace std. Then I'm using a standard namespace, std namespace, so then I can use all the objects inside that namespace, so error is gone. Cout was giving error here, but now error is gone. This is a display function. Now let us write insert function. So for insert function, I should write class name and scope resolution, then insert is taking 2 parameters, that is index and the element that we want to insert. So the procedure we already know that we should check whether the index is valid or not. Index should be greater than or equal to 0 and index should be less than equal to length. It should not be beyond length. If it is from 0 to length, then it's a valid index. Then we can insert an element at a given position. For inserting an element, I should start shifting the elements from the last element. I should start shifting the element from last element onward. So for that, I will take I. I should start from length minus 1 because the last element it has index length minus 1. Then I should continue until I reaches index and always say I minus minus. Then at a of I plus 1, I should copy the element from a of I. Means I should shift the element to a next place. This goes on in for loop. Then after shifting all the elements at the index place, I should copy an element x. Then after that, I should also increase the length because a new element is inserted now. That's all with insert function. Now let us write a delete function. For that, I will write class name scope resolution, then delete. It takes index as parameter. Now inside this delete function, I should check whether the index given is valid or not. So index should be greater than or equal to 0 and index should be less than length. If it is valid, then we can delete it. So for deletion, I should have one variable x that is initialized to 0. In this variable, I'll take the value. So first step is take the value from array at a given index. Then after taking the value, I should shift all the elements. Then for loop, I start from index onwards and I should stop at length minus 1 I plus plus. And here at a of I should copy an element from a of I plus 1. And after doing this, I should also reduce length minus minus, and finally return the element that is deleted. That's all. These are the functions I have written. Now I will develop a main function. I will remove this. Now inside the main function, you can make it as a menu driven function also, but I will write it as a simple function. First of all, I will create an array object ARR of size 10. I'll take the same size 10. Then here I will insert few elements and then delete the element. So first of all, ARR dot insert index 0 and element 5. So first I am giving index, then I am giving element 5. Then ARR dot insert, I will give the next index, that is value 6. Then ARR dot insert, I'll give an element at index 2, that is 9. Now let us display the element. So I should use object name, that is ARR, and call function display, ARR dot display. Let us run the program till here and see. I should get the elements 5, 6 and 9. Yes, I got the elements that are 5, 6 and 9. The elements are displayed. They are properly inserted. Now after this, let us try to delete an element. So whatever the element is deleted, I will try to display that element ARR dot delete, and I will delete an element from index 0. So 5 should be deleted. And then endl for the new line. Again I will display the elements. I should get remaining elements, that is 6 and 9. Let us try this. See, first 5, 6, 9 were the elements, then 5 was deleted, then the remaining elements are 6 and 9. That's all. This is working. I have tried a few functions. I have written few functions and I have tried them. Now the very interesting thing, that this array what we have created is only of type integer. If I want a float type array, then I should write a separate class. No. Instead of writing a separate class, it's possible to make a generic array in C++. So for creating generic arrays, we can create template. So template class T, instead of this integer type array, we can make it as T. Now I will show you how we can write a template class. So the class we have written, I will convert it into a template class. It's very easy. Once you have a complete class ready with you, you can easily convert it into a template. So let us do it. So on the top, I have written template class T before the class, and inside the class, wherever I want to make a generic data type, I should write T there. Now inside this constructor, an array is created of type integer, let us say T. And here inside the parameterized constructor, this also is T. Then these are display function. Now the element that I am going to insert, that should also be T. And the delete function will delete an element and return the value, so this should also be a T. Now the class ends here, so also a template ends here. The effect of this template has finished at the end of a class. Now when we are implementing functions outside the class using scope resolution, then for each function we should write down template class T, and we should use this template. See, first of all, the important thing is the class is template type, so I should write T here. Then inside this function, nothing is template. Then for this function also, I should write template class T. And first of all, I should make this class name as a T. I should pass the parameter as T for this class name. And the X value, the element that we are taking, is of type T. That's it. Inside the function, there is nothing like template. Now here, for delete function also, I should write down template class T. For each function we must write down, and the class name we should pass T as a parameter, and also change the data members if they are supposed to be template type. Like delete function is going to return template type, and this X is also a template type. That's all, everything is ready. Inside the main function, when I am creating an object of type array here in this line, I should mention the data type now. Now I am going to use it, and it's going to be integer type array. That's all. See, it was so simple. I have converted a complete class into a template class. So if you don't know this and you want to practice this, then you can watch it again and do it by yourself simultaneously. I will run the program and show you. Yes, program works successfully, the same results we got. Now let us try to take different data type here. Instead of integer, let us take float. And the values, what I will write here is 5.2 and 6.4 and 9.1. Let us see whether it works or not. Yes, it is working. 5.2, 6.4, 9.1. And the element at index 0 was 5.2, that was deleted. Then the remaining elements are 6.4 and 9.1. Now you can take any data type and you can implement this array. So I will change this data type to a character, then I will take few characters. See, first character is A, and second character is C, and the third character is D. Now A, C, D are inserted, then A will be deleted. Yes, it's working. A, C, D are inserted, then A is deleted, then C and D are remaining. So that's all with the C++ program. I have shown you few functions. The remaining function is a student exercise. You complete all the remaining function. The procedures are same as what we have learned on the whiteboard. Only the way we write the code, the style of writing the code is different. And it's not major different from C program. It's almost similar to C program. Practice this program. That's all. In this video, we will learn how to find out a missing element in a sequence of elements if the elements are stored in an array. First of all, I will show you how to find a single missing element in a sorted array if the array is already sorted. Then, if there are multiple elements that are missing in a sorted array, we will find out that. And next, if the array is not sorted, how to find the missing element. If there are one or more elements, we'll find that. So let us start with the first one, finding a single missing element in a sorted array. So here I have an example array with sequence of elements, and these are actually first n natural numbers. So the sequence is starting from 1 onwards. So if you see the elements 1, 2, 3, 4, 5, 6, then 7 is missing in this one, then 8, 9, 10, 11, 12. Up to 12 I have taken some numbers. Now I have to find out that one number, that is 8, is missing in the sequence of first n natural numbers. So what should be the procedure? So there can be more than one possible solutions. So let us look at first solution or first method. Sum of first n natural numbers. There is a formula for first n natural numbers, that is n into n plus 1 by 2. So if I have total 12 elements, so that is the last element, I should know already what is the last element. Then sum of first 12 natural numbers, this can be known by using this formula. So I can use the formula. If I know the first number is 1 and the last number is 12, and I want to know which number is missing, then I can use this formula. So for example, for this 12, if I take it as 12, 12 into 13 by 2 is 2, 6, 6 3s 18, 6 1, 78. So the total should be 78. If total is not 78, if it is less, how much less it is, that is a missing element. So what I should do? I should find the sum of all these numbers. So finding the sum of all the elements in an array, that I can do it iteratively or recursively. So let me write down a piece of program code for doing it iteratively. So for finding sum of all the elements, I'll take one variable, that is sum, and initially it is 0. Then using a for loop, I can scan through this array from the first to the last index, that is 10. So for I assign 0, so I assign 0, I is starting from 1 onwards, and I should stop at 10. So I should say I is less than 11, I plus plus. So I should know the last index, that is 10. So till I less than 11. So what I have to do, sum assign sum plus a of I, add all the elements from an array. Then here I'll be getting the sum of all these elements. Then I know the formula. Using the formula, if I know the last number, that is 12, so using the formula I can calculate that. So let us say this is n, this is n. So I can find s as n into n plus 1 by 2. So this will give me s, that is sum of first 12 natural numbers. So this should be 12. And this is number of elements in an array. Then once I got this one, then I can know the missing number from s minus sum. S is obtained from the formula, that is sum of natural numbers. I got it from the formula. Then minus a sum, that I have added all these elements. If I subtract them, then I get the number. For example, if I add all these numbers, it's like this is 10 plus these two, 20, these two, 30, these two, 40, and this is 48. Then these two numbers, 59, 71. So total I am getting 71. So this sum will be giving me 71, and for this just now I have calculated that was 78. So 78 minus 71 is a 7. So by subtracting this I can get the number. So directly I can print it here. So I will say printf missing number is s minus sum. So that's it. This is the method. You can find it using the sum of first and natural number formula. This is one approach I have shown you. Then I'll show you one more example where the elements are not first and natural numbers. The sequence may be starting from any point. So let me change these elements, then we will discuss about it. Now here I have array of elements. Now here the starting number is 6. It is not first and natural number, and the last number is 17. So first of all, I should know what is the starting number and what is the last number, right? And in this one of the element is missing. And these elements are already sorted and one of the element is missing. So I'll show you which element is missing. 6, 7, 8, 9, 10, 11, 12 is missing in this one. So there is a sequence of sorted elements. I should know the starting number and the ending number, and I want to know which number is missing in this one. And the total number of numbers are 11, that is 0 to this. So let us see how to find out this one. So for that, I will show you first of all, this is lower number, that is 6, and this is higher number, that is 17, and the total number of numbers I have, let us call them as n, and let us say these are 11 numbers, 0 to 10. Now from the 6 to 17, I want to know which number is missing. So I'll show you the procedure. See, the procedure is, if you take the indices, you can easily find out which number is missing. So here indices can help us. See, the difference between the first element and the index is 6 minus 0 is 6. Next number and its index, 7 minus 1 is 6. So 8 minus 2 is 6. So every number, if I take the difference, it is 6. Difference is 6. 11 minus 5, that is also 6. Then 13 minus 6. 13 minus 6 is not 6, it is 7. Oh, so here actually I should have got the difference as 6, but I am getting a difference as 7, means this element is missing. Yes. What should be the element? See, we know the difference was 6, right? So we are at index, which index now? We are at index 6. So in that, you add 6 plus 6 you add, that is the difference. So you get the number 12. So that is number 12 is missing. We know the difference is 6 and we are at index 6 right now. So these two 6 are same right now. So 6 is the index and the 6 is the difference. So in this way I can continue checking, and from this point onwards the difference is 7. So I should make sure that the difference is 7. So if you are sure that there is only one element missing, we can stop here because the missing element is found. And if the procedure is for finding multiple missing elements, then I can continue till end. So here I will write on the, so the procedure is, we have to scan through this array, checking the difference. If the difference is always same, if there is a change in the difference, means element is missing. So with the help of indices we can find out. So for this we have to scan through this array. So I will write on a piece of code for scanning through an array and finding missing element. Now for writing the code, I should already know these things, that is low, high and number of elements. So let us take this. We know that the array index starts from 0 onwards. So first of all, I will take difference. Difference is low minus 0. That is low only. Low minus 0 gives me the difference. So 0 I am writing so that I can show that this is difference. So starting index and this difference, it will be 6. Now using a for loop, I can scan through an array and every time I should check that the difference maintained is 6 only. So for I starts from 0 and up to n, that is less than 11, that is last index 10, what I should do every time? I should check that if for every element, if the difference is not 6. So difference of an element a of I minus I, if it is not equal to difference. If difference is not matching, then the missing element is found. So I should print this one, missing element. Missing element is index plus difference. Index plus difference. So index is I here, so it should be I plus difference. That's it. So that's it. Missing element is found, then I can break and stop end of this loop. So this break will come out of this for loop and it will stop there because the missing element is found. So that's all. This is for single missing element. Now one thing, what is the time taken for finding missing element? So we have finished finding single missing element. What is the time taken for this one? So the time depends on the amount of work we are doing. So what is the work we are doing? We are scanning through the elements in an array. How many elements are there? Some elements are there. What is that sum? N. N elements are there. So how many times we are scanning through? We are scanning through only once. So the time is order of n. Order of n, right? So order of means degree. What is big O, theta, omega? That is all different thing. So we don't need all those. So it's order of n. Yes. So the time taken for finding a missing element in an array is order of n. Now next, I'll show you how to modify the same code for finding the next missing element in an array. So I will change some elements here, then we will find multiple missing elements. Now I have more than one missing elements in an array. Let us look at the elements first. 6, 7, 8, 9, 10 is missing. 11, 12, 13, 14 is missing. Then I have 15, 16, 17, 18 and 19. So more than one elements are missing, and also from 12 to 15 if you see, continuously two elements are missing. So I have taken both the cases, that is one or more elements are missing and also continuously more than one elements are missing together. So let us see how we can find out this one. So we will follow the same logic that I have shown here by taking the difference of index and the element. So let us start how we have to modify the logic here. See, let us start from here. The difference is 6, right? 6 minus 0, difference is 6. So difference is 6. And here difference is 6. So element is not missing. Difference is 6, element is not missing. Difference is 6, element is not missing. Difference is 7. So element is missing. What is that element? Difference is 6 and the index is 4. So the missing element is 10. But the new difference is 7. Yes. So I can know the missing element by taking the index as well as the difference. So I'll get the number 10. So 10 is missing. And now from here, missing element onwards, the difference has changed. That is 11 minus 4 is 7. So this is 7. Okay, continue. Next, difference is 7. Okay, continue. No problem. Now difference is 9. Oh, so two elements are missing. So previous difference was 7 and the new difference is 9. So how many elements are missing? So right now we are at index 6. So difference was 7. 7 plus 6, that is 13. 13 is missing. And also 8 plus 6 I should take, that is 14. Then 9, oh, I should stop because the difference is 9. I should stop. So I got two elements missing. So I should start from 7, difference 7 and also difference 8. Difference 9, stop because the difference is 9 and we have that element. So for displaying multiple elements, I have to do multiple elements. So again, it means I should use a loop here. Yes. Then next, let us continue further. The difference is 9 and the difference is 9 and the difference is 9 and the difference is 9. So that's all. Everything is perfect. So we have found three missing elements, that is 10 and 13 and 14. So logic will be similar. I should take a difference and scan through. Wherever the difference is not matching, the element is missing. So let me write on the code here. So this is the workout I have done. So I'll put it in a box. I will write on the code freshly. See, first of all, we have taken difference. The difference is starting element, that is lower number 6. 6 minus 0 is the difference. And what I have to do, I have to scan through this array. So okay, for loop, for I takes values from 0 onwards and I should be less than equal to 10. So that is less than 11, less than n and I plus plus. Then every time I should check that whether the difference between the element is maintained, same difference is maintained. So index versus element. So if element at I and I itself, if we take a difference, if it is not equal to the starting difference, this one, if it is not equal, means there is some element missing, right? Now this difference may be of 1 or maybe of 2 or maybe of more. See, in this example the difference was 1, new difference was 1. Now in this example, new difference is more than 1. So I assume that it may be 1 or more than 1. So let us say more than 1 only. So for that I will display all the elements. So how to display all the elements? The current difference plus index, right? So that is 5. The current difference plus index. Right now here I got a mismatch, for example. So this is 13. If you add this 13, Then make it as 8, then this will give you 14. Then make it as 9, so it has become equal. So stop. So I should start from the current index to the new index. So if it is not equal, current difference, right now whatever the difference is less than the new difference a of I minus 1. See, this is the new difference and this is the existing difference right now. And if this new difference is not equal, then the element is missing. So while this is not equal, what I should do? I should print the element. So directly I am printing the element. Printf, the element is current index plus difference. And I should move to next difference. So difference plus plus. That's it. So using a loop, I will print all the missing elements. Present difference plus index, that is present difference. Right now, present difference is 7 plus index is 6, right? So I'll get 13. Then difference plus plus. Now the new difference is 8 plus index 6, 14. Then difference plus plus. Difference become 9 and this difference is 9. It is 9. So it will stop. Now the difference has modified. Again, the same loop will continue. That's all. So if there are multiple elements missing continuously, for them I have to write a loop here. So using a loop, I am printing rest of the elements. So this is the method for finding missing elements in a sequence of elements, and the elements must be sorted. Now how much time it is taking? See, what is the amount of work we are doing? We are scanning through the list of elements. How many times? Only one time. So the time is order of n. So if there are n elements, so the time is order of n. So if you look from the code, for loop is there. For loop, how many times it will repeat? N times. So time is order of n. But what about this? What about this? See, I am printing missing elements. How many? Will it be printing all n elements? No, just a few elements. So it's negligible. So overall, if you see, the number of time the process is done is from 6 to last number 19. So this loop will repeat from 6 to 19, and this loop will print the missing element. So 10 is missing, so that is printed. 13, 14 is missing, so that is printed. So those elements are also included. So without missing all the elements, so this loop is accessing all the elements, missing any element. So it means we don't have to consider the time taken by this loop because this time is negligible. Just it is filling up the gaps, that is missing elements. So the total time is order of n. So time taken by this algorithm is order of n. So that's all. This is the method how to find a missing element, one element or multiple elements in a sorted array, and the sequence of elements may be starting from 1 onwards, may be starting from any other number. So this procedure I have shown you, this you have to write down the program and execute it. So you can write a main function, and in that you can declare an array, and inside the main function only you can write down this logic and check it. So this is a student exercise. And in the next video I will show you how to find a missing element in a unsorted array. Now let us see another method which may be a faster method for finding missing element in sequence of elements. So the same example, I have set of elements that are starting from 1 and ending at 12. So 1 to 12, and some elements are missing that are 5 and 8. We already know that. And the previous method was taking order of n square time. Now for making it faster, I have taken an array here. That is array from 0 to 12. The last index is h is 12, so the maximum element is 12, so I have taken an array till 12. So first of all, take an array equal to the size, that is the maximum element you have in the sequence. Then initialize the array with 0. Okay, initialize. Now what to do with this? I'll show you the procedure. See, scan through this array one by one. Now let us see the procedure. See, scan through this single dimension array, taking one element at a time. What to do for each element? First element is 3. Go to index 3 and increment it. Make it as 1. So it was 0, just make it as 1. Then next 7. Go to index 7 and make it as 1. Increment it. 4. Go to index, then increment it. 9, go to index 9 and increment it. Go to index 12 and increment it. Then go to index 6, same thing, 1, increment, 11, increment, then 2, okay, increment, then 10, increment. So I have scanned through this array, and for that particular element I have gone into the same index, like for 11 I went into index 11 and incremented that value. So now in this array I have all those location marked as 1 for the elements that are present in an array, and the missing element they have still zeros, like 0 0 0. Anyway, this 0 is not there in our sequence. Our sequence starts from 1 onwards, so ignore that one. So from that point, from 1 to 12, if you see, there are two places that are still zeros, means the elements are missing. So this procedure looks simple and faster. Yes, what is the work we have done? Let us analyze the time, then I will show you the code. So first let us analyze the time. So the time taken is, we are scanning the list of elements. Yes, then for every element what we are doing here, at the same index we are incrementing it. So how much time it takes for incrementing it at the same index? Constant time, because I don't have to search anything. Like if it is 1, go to index 1 and increment it. Like if it is 12, go to index 12 and increment it. So the time taken is constant. So majorly where the time is spent, we are scanning through this list of elements, so that is order of n. So yes, the time taken is order of n. So this is the faster method. Yes, this is the faster method. Now this is one of the suggestion which is faster. Now one more thing in analysis. What do you call to this such an array? Now one more thing in analysis. What do you call to this array? See, I have given the name as H. So usually this is hash table. Hash table, we'll learn it later, but the simple implementation of hash table, hash we are saying because whatever the element is, we are going to that same index and accessing it. So this takes constant time. Remember that hash table takes constant time, that is ideal time for hashing is constant. So this is taking constant time for storing those elements here, right? So this is hash table, or else we can call it as bit set. So we are taking the set of bits for each number and we are marking them, and whichever are zeros, those elements are missing. Yes, this bit set, we have not implemented the complete mechanism of hashing technique, like using a hash function, all those things, but this is the simplest form of hashing. Remember, whenever you have to search, you can apply hashing if possible. Then one important thing about hashing, when you are using this array as a hash table and storing the elements, then you need an array space equal to the largest element. So it is 1 to. So this may take a lot of space. So space, if it is a constraint, then you cannot use this hashing. Means if you have limited space, then you cannot think of hashing. But nowadays the machines that we are using, they have abundant memory space, so we hardly bother about memory space. So hashing is a best solution whenever you are searching something. So yes, we have used hashing and reduced the time. See, remember in the previous method the time was order of n square, now it has reduced to order of n. It's a big change. And using this approach you can solve various problems. So this you can take it as a basic idea, not just a solution to a problem. Now I will write down a piece of program code and I will explain. See, for writing a program, first of all, I must have array of elements, list of elements, starting index and the ending index and the number of elements. And also I should have an array. Dynamically you can declare an array of that given maximum size and you can initialize it with 0. So assume that that part is already there. Just I will scan through this list. So for scanning through this array, I will take a for loop for I assign starting from 0 and I is less than number of elements that are n. So less than n, I plus plus. Then what I should do every time? See, if the number is a 3, a of I initially is 0. A of I is a 3. So I should go to index 3 and mark it as 1. So incremented. So a of I, which is 3. So I should go to that index in h. So h of a of I that I should increment it. That's it. So it will scan through this array, and for every element in that particular index, it will increment it. So this for loop will increment wherever the element is found. Then I have to scan through this array and find out missing element. Wherever is 0, that element is missing. Simple. So I will write on one more loop. This is over, right? After this, the next for loop, for I assign, I should start from which element? This element to this element. That is low, and I is less than equal to high, I plus plus, right? So I should start from 1 and add 12. Then every time I should check if h of I is still 0, means element is not there. So simply I will printf. Which element? Like h of 5 is 0, so 5 is not there, right? So printf percentile d, new line, and I will say I. So that's index. So that's all. In a single line I have written it. So this for loop is for scanning through this array, and this for loop is for scanning through this array. So this is also order of n, and this for loop also number of elements are n. Total it is 2n, so I can say it's order of n. Degree of a polynomial is n. So this for loop n times, so n elements, so 2n, and time is order of n. So that's it. So you can write on this program and check it. So you can directly write inside main function, and you can execute this program. So this is a student exercise, so you have to do this one. That's it. Now the next challenge is finding duplicate elements in an array. That is duplicate elements in a list. So in this video we'll be looking at finding duplicates in sorted array, and also how to count those duplicate elements. So if you look at the example what I have taken here, 3, 6, 8, 8 is 2 times, 8 is duplicated, and 10, 12, 15, 15, 15, 15 is duplicated, and that is 3 times. So first I will show you how to find the duplicates, then also I will show you how to count them. So let us develop some procedures for finding duplicates and counting duplicates. Let us develop a procedure for finding duplicate elements in a list. So for finding duplicates, I should scan through this list. So total number of elements in the list are 10. So let us say I have number of elements that are 10. Now let us see what we have to do while scanning through a list. So I'll take a counter I, and I will scan through the list. So let us take I. I is 0. So being here, I should check whether the next element is same as this one. So at a of I should check a of I plus 1. Is it same? These are same? No. So quietly move ahead. Then, is it same? The next element is same. Now I is at 1. Check the element at next location. No, it's not same. So move ahead. Now, is it same? Yes. So a duplicate is found. So wherever I is pointing right now, there is a duplicate element. That is, that element itself is duplicate. So okay, display 8. Then move on to the next element. So now here, again check the next element. See, being on one element, we are checking the next element. Is it the same element? No, it's not duplicate. Then is it the same element? No, it's not a duplicate. Is it the same element? No. Is it the same element? Yes. So 15 is found, so we can print 15, that is duplicate element, and move next. Now see the difference here. If I move next and again check the next element, being here if I check the next element, it is same. So it is again 15. So shall I print 15 once more? No. So I should print 15 only one time. Right? So this I have to take care. If a same number is duplicated more than 2 times, then I have to take care of that situation also. So here it is duplicated more than 2 times. So let us see what I should do. So I'll again start the procedure and see how we can proceed for this one. I'll take one variable here. Let us call it as last duplicate. Last duplicate, initially let it be something, let us say 0. Now let us start once more. See, for this problem, handling this problem, we are using this one. Now same procedure. Next element, is it same? No, it's not a duplicate. Next element, is it same? No, it's not a duplicate. Next element, is it same? Yes, we got a duplicate. So last duplicate, I'll remove this 0 and keep it as 8. So check the last duplicate. Last duplicate, is it same? No, this is 0. So this is a new duplicate we got. So print this 8 and change it to 8 and move to the next element. Now check the next element. Is it same? No, it's not a duplicate. Next, not a duplicate. Next, not a duplicate. Now being here, 15. So next element, yes, 15. It's a duplicate. Is it the same one that we found it at the last? No. So print that 15 and change it to 15 now. Change it to 15 and move to the next element. Now, again, next element is duplicate. But is it the same element last duplicate we found? Yes. No need to print. So if that same duplicate is there, don't print it. So that's how. Just you can maintain one variable to keep record of last duplicate found. That will help you if there are multiple occurrences of duplicate element. So that's all. This is the procedure. So that's it. This is the procedure. Now let us write the program code for it. I will take one variable called last duplicate and let us set it as 0. Now I have to scan through this array, so that I can do it using for loop. So this for loop will take me through all these elements in an array. Then every time what I should do, being on one index, I should check whether the next element is same. If it is the same, then I got a duplicate. So check if a of I is equal to a of I plus 1. So if these are same, I should check that. And also I should check that it should not be equal to that duplicate and a of I is not equal to last duplicate. So if these two conditions are true, then I got a new duplicate, so I will print this one. So printf print an element at a of I and also modify last duplicate to this a of I. So that's all. This is the procedure. So if the next element is same and it is not same as last duplicate, then it will be printed and we will record this new duplicate so that we don't print the same thing next time. So that's all. This is a student exercise. So you can write on this program just as a part of main function. You can do it. You can take an array of these elements and you can write the rest of the code and you can check what the results you get. So it should print the duplicate elements. Now next I will show you how to count the number of duplicates. Like 8 is appearing 2 times and 15 is appearing 3 times. So let us see how we can count this. Now let us see how to count. The procedure will be same as finding duplicate. Just now we saw the procedure, but only the difference is we also have to count how many times it is appearing. So let me devise a procedure. Let us check. So I will scan through this list of elements one by one and the procedure is same. I will be checking whether the next element is same. No, it's not same, so it's not a duplicate. Next element, is it same? No, it's not same, so it's not a duplicate. Next element, yes, it is same. Yes, it is same. So once you got a new element, so once we got a duplicate element, what we can do is we can count how many times it's appearing. So we can continue counting from there. So what I will do is next element, I will keep it as j. That is another counter. That is for counting. And keeping it as j, I will check whether this is same as this one or not. Yes, it is same. Then j plus plus. Is it same as this ith element or not? No, this is not same. This is different. So stop. We got the number of duplicates. How many? See, j is 4 and I is 2. So 4 minus 2 is 2. So we got 2 duplicates. Now once we have finished this counting, I should move to this element, that is I should move to this location, that is j minus 1. So from here I can continue smoothly because next in a loop it will be I plus plus and it will automatically go to the next element. So let us continue the procedure. This is over, right? Now again continue. Is it same? No, not same. Next, is it same? No, not same. Is it same? No, not same. Is it same? Yes. So when it is same, again you can start j from here and go on incrementing j. Is it same as a of I? Is it same as a of I? Yes, it is same. So j plus plus. Is it same as a of I? No. So from I to j we have the duplicate element. So what is the element? That is 15. How many times? So j is 9. 9 minus 6, that is 3. So 15 is appearing 3 times. Then bring I here and check. If next element is same, no it's not same. So I, when it reaches the last index, it should stop. So in the for loop I should say n minus 1. I should not go up to n. We are using two indices, I as well as j. I am using simple names, that is I and j is helping us to count. So let us write down the code for counting. So the code will be similar to the duplicates code, just here we are counting with the help of j. So I will write down the code. So for scanning through the list of elements, I need a for loop. So for will start, I will start from 0, I should less than n minus 1, right? So in the previous example, I wrote n here, it should be n minus 1, means the last position is here, I should stop here. Beyond this, there are no elements. Then I plus plus. Then what I should do? See, when I is here, I should see that if the next element is same. So yes, same thing, if a of I is equal to the next element, that is a of I plus 1. If it is same, then what I should do? I should start j from here. I can start from here and make it move until it finds a different element. So j should stop here. So inside this, I can say j assign I, or I plus 1 also I can write. And I should move j while a of j is equal to a of I. As long as it is equal, I should go on moving j. So say just j plus plus. So here I have not written any brackets or anything. This is a part of while loop, right? In a single line I am writing it. Then once j stop at some place like here, then the difference between these two is the number of times 8 is duplicated. So I can print this one. Printf. I will print the duplicate element and the number of times. See, percentile d is appearing percentile d times. So who is appearing how many times? J minus I times. J minus I times. Then after this, I should make I come on to this location. Now after this, I should move I to a location just before j, because in a loop, again, I plus plus, I will be definitely moving. So I should be j minus 1. That's all. I is used in the for loop. Can we modify it inside the for loop? Yes, you can modify it. So now already these two elements are finished. So I was here, so I can bring I here. So next time I plus plus, again I starts from this point. Now again it will check this element with this one and this with this one, so on. So that's all. So just by using a j variable, I am counting the number of elements. Now next thing is analysis. I want to know how much time this procedure is taking. So what we are doing in this one? We are scanning through all the list of elements. How many times? Only one time. We are scanning from left to right. See this for loop. Even in the duplicates, displaying duplicates as well as counting duplicates, the logic is same. Only difference is we also have one more while loop inside. Then, do we consider this while loop? No need. No need. Is it covering the entire array? No, just a part of an array. Part of an array. So it's negligible. And even when we have moved j to some location, we are also shifting I. So those elements, whichever elements we have covered, so the elements covered by j, we are skipping it I. So we don't have to count it. So this loop is negligible. Though while loop is there, it's not doing extra efforts. So the time is equal to the number of elements. That is number of elements, we can say n, order of n. So the time is order of n. So this is the analysis for finding duplicates and counting duplicates. Now next I will show you one more method, that is using hash table. We can find duplicates and also count duplicates. So let us see another method. Now let us look at a second procedure for finding duplicates in a sorted array. Already I have a sorted array and there are some duplicate elements like 8 is duplicated and 15 is duplicated. We want to know how many duplicates are there, and also we want to know count. Like if 8 is duplicated, how many times it is duplicated? If 15 is duplicated, then how many times it is duplicated? Now for this second method, I am using hash table. So this is the simple form of hash table, right? Though we don't know what is hashing, we have it in the last section, but just we are using a simple form of it. So this is an array actually, and the array size is 20. Why I have taken array size as 20? Because the largest element in this array is 20. So just you can go at the end of a list because it's a sorted. So the last element gives you the size of this array. We should have an array equal to that size. So if it is 20, I must have an index 20, remember this. So I should create an array of size 21, right? Then I get the starting index as 0 and the last index as 20. Then next, this should be filled with zeros. Yes. Then what is the procedure? Let us look at the procedure. So let us scan through this array by taking one element at a time. So for that, I will take a index pointer, that is I, starting from here. Now while scanning, check the element. Element is 3. So here, go to index 3 and mark it as 1. Increment it, right? Then move I to the next element, go to index 6 and mark it as 1. See, going to the index 6 and mark it as 1 takes just constant time. I have to say h of 6 plus plus. That's it. It's simple. Then go to the next element, 8, mark it as 1, increment it, right? The next, increment it. So actually this was 0, so I have marked it as 1. Now again 8 means make it as 2, increment it. Then 10, increment this one. Then 12, increment this one. 15, increment. So again 15, so make it as 2. Again 15, so make it as 3. So finally I wrote 3. Then 20, make it as 1, increment it. So scan through this array of n elements once and mark these or increment the count, right? So now in the hash table you can find that which element is appearing for how many times. So here we got the results. Now before showing in the code, let us do some analysis. How much work we are doing? We are doing nothing but scanning through this array. So how much? N, right? Then how many times? Only one time we are scanning. Then where is the result? And while scanning, we are marking this, that is incrementing the counts. How much time this is taking? Like for 10, I directly went to index 10 and I have incremented. Like for 15, I directly went to index 15 and incremented. So incrementing this take constant time. So what is the major time we have spent? N, accessing this one. Then next what we have done? We have to find out what are the duplicate elements from this hash table. So we can scan through this one. This is not there, this is 1 time. Okay, 1 time. This is 2 times. Then this is 3 times. So I have to scan through this array also. How much time it takes? Plus n. How it is n? See, that are only 10 elements. These are 21 elements. So 10 means here not count. See, when we say n is the size of the input, n means size of the input to an algorithm, right? So in this procedure, n is the size. Okay, whose size? This size or this size? Whatever it may be. We are not bothered about exact figures. Here, now listen carefully. N means linear. Yes. Then what about this? Linear only. So what I should say? N only. If you say no, this is larger, okay, you take it as 2 times of n, no problem. No, still larger. So whatever you want, you write on k of n. So this is also linear. Then if I take it as only n, then I say 2n. So what is 2n? 2n is also linear, right? So finally, it is order of n. Yes, it takes order of n time. So this is the analysis. Now I will write on the procedure and show you how we can mark these elements or count them and also display the result. So the procedure is I have to scan through this array. So for that I will take a for loop. For I assign 0, I should go till n, suppose number of elements are n, then I plus plus. Then for each element, like a of I is what? 3. So for a of I, right? A of I means let us say 3. So I should go to third index. So that is h of a of I. Yes. A of I is 3. So that 3, I should find the index here, right? So h of 3 plus plus, this will increment. So that's all. This is how I can mark them or increment them. This is over. Now the next step is go through this hash table array, and wherever we have count more than 1, print the element. So here for loop once again. For again I will take I. See, this is not inside this for loop, this is independent for loop, right? For I assign 0, I is less than whatever the maximum number is. So less than, or I is less than or equal to whatever the maximum number is. Like here we have maximum is 20, so up to 20, and I plus plus. What we should do every time, if that value here, the value is greater than 1, if h of I is greater than 1, then we will print. So in the same line I will write on printf. Here printf %id %id, I gives the number and h of I gives the count, how many times it is appearing. That's it. It's a simple procedure. Let us do the analysis. See, this for loop is repeating for some number of times, so it is n. And this is independent for loop. It's not a part of that one. See, this for loop was n. Now this is independent for loop, and it's also repeating for some number of times, so it is n. So when you have a single for loop, it is n. If you have for loop inside for loop, then it's n square. So this is n plus n. So this is 2n, and time is order of n, right? Or big O of n. So the time is order of n, or big O of n. So we have done the analysis from the code also. So that's all. Finding duplicates and counting how many times it is duplicated. You can write on this procedure. You can write a simple program, take an array and one more array for hash table, and write on this code and see, right? So it's a student exercise. That's it. In this video, we'll look at a procedure for finding duplicates in an unsorted array. I have an example array. Here the elements are not sorted, and there are some duplicate elements present here in this array. Like 8 is appearing 2 times, and 6 is appearing 3 times, and the rest of the elements are unique. Now I want to write a procedure, find out duplicate elements, and also I want to count them, how many duplicates are there. So there can be more than one solutions. So first solution let us look at. We will scan through an array, we'll pick up an element and look for its duplicate. Like 8, we will check in the rest of the array and find out is there any other 8 present in an array. Next we'll pick up 3 and check in the rest of the array to find if there is any other 3 present in an array. So I will demonstrate in this list. So for demonstration, let us take one variable, count, and initially let us say count is 1. Now start from here. This element I am counting it for 1 time. Now from here I should check in the rest of the list, is there any other 8? So for that I can take one more variable, that is j. With the help of this variable I will scan through this list and find out if there is any other 8. So let us start. Is it 8? No. Move j to next location. Is it 8? No. Is it 8? Is it 8? No. No. Yes, it is found. So once it is found, 1 to this. So now we have 2 8s. Continue. So is it 8? Is it 8? No. So we have finished looking for a duplicate of first element 8, and we found 2 elements. So count is 2 means yes, there are duplicates. Already we have taken that 8 into count. So we should not count it again. It may happen that the same element is counted multiple times. So we will see that situation. So for that, we should remove that 8, or we should have some marking to show that that is already counted. So for that, I will take -1 in this place. So whenever a duplicate is found, just mark it as -1. -1 is element is not there. Alright. Now let us continue. We will find the duplicates of other element. Then I can explain you what is the reason of taking -1 once again. Now start. I will find the duplicates of next element 3. So make this as count as 1. Now using j, go on looking for 3. 3 is not there. Now take j from here and go on looking for the element 3. by comparing the elements. Next, 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 next. So 3 is not there. So count remains 1, means there is only one copy of 3. Now let us take the next element, 6. Now here I am at 6. Now start finding 6 using j. Is it 6? No, it's not 6. So move j to next. Is it 6? Yes. So count. Then again move to next. It's not 6. This is 6. So count. Then this is minus 1. Leave it. It's not same. So this is 2. This is 7. I have came across 2 more 6. Right? I am finding the duplicate for this one. So I should mark this as minus 1. Yes, minus 1, minus 1. Now count is more than 1. So it means there are duplicates of 6. Next, let us go to the next element. For 4, if I find in the rest of the array, there is no other 4. So count remains 1 for 4. Now take the next element. Now the point is, shall I take this element or not? If I take this element, then again I will get the result that 6 is appearing 2 times. I should not take that element because already it is counted. Leave it. So it's a duplicate element. So I have marked the duplicate elements. Otherwise, I may be getting duplicate results. Otherwise, I may be getting extra results that for 6 it appear 3 times. Again from here 6 appear 2 times. So that is the reason I am marking them. So this is the procedure. Now before showing you the program code, let us do some analysis. How much work we are doing. See, we have started finding a duplicate element of 8 first here. So for finding duplicates, I am comparing with the rest of the elements. So if there are total n elements, then how many elements I am comparing? N minus 1 elements I am comparing. Then again, being on 3, I am comparing the rest of the elements, right? I don't have to check on this side. I have to check the rest of the elements. So total how many? N minus 2 elements I am comparing. Then being on 6, I am comparing n minus 3 elements. So n minus 3 comparisons I am performing. Then same way, it's go on reducing up to last 3 comparison, 2 comparison and 1 comparison. So these many comparisons I am doing. So total how many comparisons are these? These are n into n minus 1 by 2. N into n minus 1 by 2. So this is n square minus n by 2. So the degree is n square. So it is order of n square or big O of n square. Though we don't know what is big O omega. So let me call it as order of, that is. So I'll be simply calling it as order of, that is degree of 2, that is n square. Degree is 2. So it is order of n square. Right? Now let us look at the procedure. So I will write on the procedure for this one. For finding duplicate, I have to start finding the duplicates of the first element. So I should start from here. So one is I, that start from 0, and I should stop here because I don't have to check for the duplicates of this element. I should stop at this point at last. So that is less than n minus 1 I plus plus. Right? So this is the main loop that is going through all the elements to find their duplicates. Then every time I should start count with 1. Okay, count with 1. For every element, count as 1. Then find are there any more elements to increase the count. Now, when I is here, I have to scan through the rest of the list, right? So I am starting j from here and continuing till the last element. So I will take one more for loop for this j, that is j assign I plus 1, that is next element of I, and it should go till the last element, so it should be less than n and j plus plus. Then what I should do, like for 8, if I have reached here, means the element is matching. So I should compare this element with this one, and if they are matching, I should increment count. So here I will set if a of I is equal to a of j. If they are equal, then I should do count plus plus. Yes. Then, as I said, also I should mark this as minus 1. So at a of j, I should make it as minus 1. So count plus plus j minus 1. Then end of this loop. Now once I come out of this loop, I should check what is the value of count. If count is greater than 1, then means there are duplicates. So here I will write down printf if count is greater than 1, Then print. So here I am printing percentile d percentile d. First is a of I, that is 8, and count means how many times it is duplicated. So this will print this one if count is greater than 1, means there is a duplicate element, and how many times it is duplicated, both I am getting. So end of this loop. Now one more thing, this checking for the duplicate I should do if it is not -1. So here I will write on the condition if a of I is not equal to -1, means for this element I should not find the duplicates, right? Because already it has become -1. So for this one I should not do, right? I should not enter into this one. So this is conditional. So that's all. This is the procedure for finding duplicates and counting how many times each element is duplicated. Already we have done the analysis. Now let us look at the code and do the analysis. See, from the code, this loop is repeating for n-1 times, so almost n times. This will repeat for almost n time. And this is starting from I plus 1 till n. So this is also repeating almost for n times, right? We already know the working. Based on that we are saying that, right? It's not just by reading the code. We know the working. It's starting from I plus 1 till n. So this is also almost n times, right? Otherwise, if you want to consider in detail, this will be reducing one by one. n-1, n-2, n-3. So if I sum up, again it was becoming n square. So now roughly I am writing it as n. So this is n inside n. So there is a for loop inside for loop. So the time is n square. That is order of n square. So that's it. This is the procedure for finding duplicates. So you can try this by yourself. It's a student exercise. I have written the code on board. Just you have to write a main function, and inside the main function you have to declare this array and write down this similar code and see the results. Now let us look at the second method for finding duplicates and counting duplicates in a unsorted array. So this is using hash table, a simple hash table, or also you can call it as a bit set. So let us see the procedure. I have the same array here having duplicates, that is 8 is duplicated and 6 is duplicated. Now I have to take a hash table array, and the size of the array should be equal to the largest element in the array. So if you check in this array, the largest element is 8. So I have taken till index 8, means total size is 9, because starting from 0 onwards. Now the procedure is I should scan through this list, and for each element I should increment the count here in this hash table. So let us do it. Start from first element 8. Go to index 8 here and increment it. Then move to next element 3. So go to index 3 here, so increment it. And 6, go to index 6, yes, increment it. 4, increment it. 6 again, so 6 should be made as a 2. I'll overwrite it. Then 5 is 1. Then 6, I will overwrite this one. This is 3. Then 8, this is 2. Then 2, this is 1. And 7, so this is 1. That's all. I have scanned through this array only once. Yes. So if I analyze how much time I have spent, order of n time. So I'll just write n. Now next what I have to do, I have to scan through this hash table wherever I got a value that is greater than 0. Yes, this is greater than 0, greater than 0. Yes, wherever I get the values greater than 0, element is present there. And if the value is greater than 1, then duplicate is present there. Like this is 1, so this is single value, 3 is single, 4 is single, 5 is single, 6 is appearing 3 times, right? 6 is appearing 3 times. And this is 7 is single and 2. So 8 is appearing 2 times. So I got the elements which are duplicate, and also how many times they are duplicated. I got both of them. And for scanning through this, let us say time is n, because actually n means here linear. Actually n here means it's linear, right? Linear. So this is linear list of elements, whatever the size may be. Don't check that this number of elements are different, this is different. If that is n, this is n-1. No, n means linear in simple terms, right? So this is also linear. So linear plus linear is 2 linear. So 2 linear is also linear only. So it's order of n. So So 2 times of linear is also linear. So I will not write down the code, right? So already we have seen this in missing elements. So logic will be similar. You can write down the code for this one. So this is also a student exercise. So you can write on the main function, in that you can take this array and then write on the code for finding duplicates and also displaying their counts. So that's it in this video. In this video, we'll learn about a problem, a challenge, that is, if a list of elements are given, then we have to find out a pair of elements, so that is 2 elements, such that their sum is equal to some given number. For example, we want 2 elements A and B such that their total is equal to 10. As per my example, I have taken 10. So we have to check in this array, are there any 2 elements whose sum is equal to 10? So let us check it directly. 6 is there. So I need 4 so that it becomes 10. Is there any 4? No. Then 3. I need 7 to get the total as 10. Check for 7. Yes, found. So we have a pair of elements, that is 3 and 7, which is forming total 10. Then 8. I need 2 for this one. So check for 2. Yes, found. So we have one more pair of elements whose sum is 10. Then 10. So already it's 10. So I should have zeros. Check for 0 in this remaining list. No, 0 is not found. Now one thing, why I'm not checking this side? See, this side already I have compared with the rest of the elements. Right? So I have to check forward only. So now 16, this is greater. So anyway, if I check, there is no pair found. So this is not equal to 10. There is no pair. If there is any number, it should be negative number, that is -6, right? Then 7, there is nothing here. Then 5, there is nothing. 2, nothing. So this is how I have found out that there are 2 pair of elements whose sum is equal to 10. Now we need an algorithm on this one. So I will show you first method. Let's look at the first method. See, I have to scan this array. So for this, I will take one variable I. Now for this element 6, I need a pair. So I have to check the rest of the array. So for checking in the rest of the array, I should use J. So J will help me find out an element such that whose total is equal to 10. So this J, I have to go on increment it. So using this J, I will check this total is not 10, then move J to the next element and check, is it equal to 10? No. Next, is it equal to 10? No. So in this way, I can go on checking the elements. So this procedure is same as how we were finding duplicate elements. Yes, it is same. Only the thing is, that time we were checking, is it a duplicate element? Now you have to check whether the sum is equal to 10. That's it. It's simple. And one more thing, I have taken unique elements. There are no duplicate elements here. Like if I have 3, then 1 7, then one more 7 I have. No, there are no duplicate. All elements are unique. So you don't have to worry about any duplicate elements. If at all there are duplicates, then you should remove the duplicates and perform this procedure. I will quickly write down the program code for doing this one. So let us see. For scanning through this element, I need a for loop. So I'll write a for loop for I assign 0. And I should go up to last element because I don't have to check this element, right? There is nothing beyond this. So I is less than n minus 1 and I plus plus. Then for every element, I should try to find a pairing element such that total is equal to 10. So for that, I need J starting from the next element onwards. So for that, I will start J assign I plus 1 onwards. Then J is less than, till last element I should go, less than n, that is J plus plus. See, remember here n value is 10, right? There are total 10 elements. So the last element is at index 9. Now what I should do every time, if A of I plus A of J is equals to given number, let us say given number is K. If it is so, then print both the element. See, the printf will print A of I value, A of J value. Like suppose I is here right now, I is here and J is here. So A of I value, that is 3, A of J value, that is 7, 3 and 7. So it will print 3 plus 7 is equals to K. So that is equal to 10. Yes. So we got the pair of element whose sum is equal to K. That's it. This is the end of loop and this is the end of loop. So that's all. This is the code for finding a pair of elements. Now, analysis. How much work we are doing? See, amount of work we are doing is similar to finding duplicates, right? See, being here on I on this place, we are checking rest of all the elements. So how many elements we are checking? Let us say n minus 1 elements. Then keeping I here, we are checking rest of the elements. So this is n minus 2. So this is same way, this is going till 1. So this is n into n minus 1 by 2, and this is order of n square. So yes, time is order of n square. So this is quadratic time taking procedure, right? N square means we say quadratic time taking procedure, right? Here n square doesn't mean exactly 10 into 10, that is 100. It doesn't mean that. It's n square, that is quadratic time taking. So if you look at the code also, here is a for loop. The outer for loop is there, so I can say it is n because it is going starting from 0 and ending at n minus 1. Then inside that, one more for loop that is also going till n, but from where it is starting? Just beside I onwards, right? So it's almost n. If you say no, it's reducing, so this was the analysis. Yes, n minus 1, n minus 2, that's how it is reducing, and the total is again n square. See, the degree of this polynomial, if I take the degree of this polynomial, this is n square minus n by 2, degree is n square. So we are saying this is quadratic. So even if I do detailed analysis for this one, it will be n square only. So I'm assuming roughly it as n. Now when to assume this for loop as n or when ignore it? Because in the previous example, I said that I wrote while loop and I said that it's negligible, we can ignore it. But here I am saying it should be considered. So for that, you should have the good understanding of the procedure that is being done here. If you understand the procedure, then you can decide whether it is considerable or not. You can judge that one, right? So this comes with practice. There is no formula. I cannot say that if this is starting from here to here, say n, otherwise do like this. No, it's all based on the procedure. So there are a lot of things to learn, right? So meanwhile, you'll understand how to analyze a procedure based on the code. Right? So now it is n, and inside that there is one more n, so it is order of n square. So by reading the code also, we have found that it's taking order of n square time. So this is time consuming method. I want a faster method. So for faster method, again the solution is hashing, hash table. So I'll show you how it is possible. So quickly I will show you that procedure. Now let us look at the second method for finding a pair of elements whose total is equal to given number, that is 10. This method uses hashing. So for hashing, I have created a table which is already initialized with the zeros. The size of the table is 16 because the largest number present here is 16. So yes, already we have discussed that when you are using hashing, then you need a lot of memory, and it depends on the maximum element that you are dealing with. Now, what should be the procedure? So simply we will scan through this list of elements and we will use this hash table, increment the value or mark the value. Let us do it. And while marking, while scanning, what all we have to do, let us check it. So let us scan through this array. This is 6, right? Mark 6. Okay, this is marked. And for 6, which number is required to make it as 10? So 10 minus 6 is 4. Look for 4. 4 is there? It's not there. So there is no matching for 6. Then let us take I on the first element. Let us take I here. This number is 6. Now for making up the number as 10, we need 4. So check on index 4. Is it marked? No. 4 is not there in the list. It's not yet found. Maybe it's there, we don't know, but it's not yet found till here. So 6 cannot be a pair of element, right? So but 6 is there, so mark it as 1. Then move to the next element, 3. Now which is the element we need for making it as a 10? So we need 7. Go to the index 7. No, 7 is not there in the list, but we found the 3, so mark 3 as 1. So I'm saying count, I'm just incrementing the value, right? Then next is 8. So for 8, which number I need? That is 2. So go to index 2. So 2 is not there, right? So 2 is not there, it's not found, so there is no matching pair. Anyway, we got this 8. So increment this, so mark it as 1. Then 10. So for 10, I need 0. 0 is not there, but we got 10, so mark it as 1. Then 16. For 16, there should be minus 6. There is no such index. Then next, 7. For 7, I need 3. Yes, 3 is already marked. So it means 3 and 7 make a pair whose sum is 10. So yes, we got the result. We will display this result and also will mark this as 1 because this is already there in the array. It is found. Then go to 5. 5 is marked as 1. Then for 2, we have to check 8. Yes, it is there. So 2 and 8 makes a pair and also mark it as 1. Then for 9, check for 1. 1 is not there. So anyway, it is found. So make it as 1. Then for 14, check for minus 4. Minus 4 is out of index. So anyway, this is found. So mark it as 1. So this how we can go on marking the elements and finding out whether there is a element whose sum is equal to 10. So that's all. This is the procedure. Now what about the analysis? I will not do analysis. You know the result already because already we have used hash table, right, in the previous examples also. So the time taken is order of n, right? It's order of n. Now let me write on the code for this. So I will write on the program code which will use this hash table and find out a pair of elements. So here I will write down. So what I have to do basically, I don't have any work here. I have to scan through this array. Yes, for I assign 0 and I is less than, that is last element n and I plus plus. Then what I have to do every time. Now being here, I should check here whether 4 is marked or not. So check whether in the hash table at 4. So right now this is 6, so I have to check for 4. So that is nothing but 10 minus 6 I have to do. So 10 minus 6 means 10 is a k and minus 6 means a of I, right? A of I. See, 10 minus, for example, if it is 6 gives what? 4. So this will be h of 4. H of 4. We are checking at h of 4. If h of 4 is not equal to 0, means it's already found. It's already found. That means there is a pair. So what is the pair? So I can print these elements. So I am printing these elements. The elements are, that is a of I, that is the first element. Then next is the difference between them, right? We have checked at 4, so that is difference. So k minus a of I, that is the difference, and also k. So the output is first element plus second element is equal to k, that is 10. For example, it is 10. So this will be printed. If this is not equal, right, equal to 0. Anyway, after checking this, if it is found, then we will use this. Then afterwards, definitely we have to make this element, that is 6, as 1. I will increment it. So that is h of 6 as 1. So h of 6, what is 6? A of I. A of I as 1. So for 1, I will simply say plus plus. So this will increment. So that's all. So this is the procedure for finding a pair of elements with the help of hash table, right? So this algorithm takes order of n time. Order of n time. This is scanning through these elements only once. Yes, it's faster, but the space taken is more. So always remember this, there is a trade-off. If you want to save the space, then time will be more. If you want to save time, then space will be more. That's all in this video. In the next video, I'll show you how to find a pair of elements in a sorted array, if the array is sorted. In this video, we will solve a problem to find a pair of elements in a sorted array such that their total is equal to a given number, for example 10. We want a pair of elements A and B such that their total is equal to 10. So in my example, I have taken 10, it can be anything. So for any given number, we have to find out pair of elements if it is existing in an array or not. So already I have an array which is already sorted. So in a sorted array, how to find this, we will see. I'll show you the procedure. See, we want a pair. So first let us check whether there are any elements or not. Like, 1, 9, it's there. And 4, 6 is also there. Yes. So we have two pair of elements whose sum is equal to 10. So how to find out this? As the array is already sorted, all the smaller elements are on this side and the greater elements are on that side, right? So we want a pair of elements. So when there is a pair, then one number may be smaller and one number may be larger, right? Like 3, 7 or 2, 8. So that is total is 10. So smaller numbers are on this side, larger number on that side. So we can start scanning the array from either direction, from both the direction, to find one small element, one large element, so that the total is equal to 10. Yes, we will follow this idea. So for scanning through this one, so I will take I, that is starting on 0, and j on last index, that is n minus 1. Then using this I will proceed in this direction, j I will move it in this direction. Then what I have to do every time? Check whether these two are equal to 10. No, this is greater. This is greater. 1 plus 14 is 15. That is greater. So when it is greater means because that number is greater. So this is greater. The reason is that number is bigger, right? So let us check a smaller number. So I will decrement j. I will not increase I. Let I be there only, right? Now again check. 1 plus 12, 13. This is still greater. So because of that bigger number, we are getting the result greater than 10. So let us decrement j only, right? Let us decrement j only. Now this one, 10 plus 1, 11. Still it is greater than 10. So decrement j. Now 1 plus 9, yes, we got a pair. 1 and 9 are together forming 10. So yes, we got a pair. Next, once we got a pair, then we should increment I also and decrement j also, right? Both are done. Both I have done. Now watch. 3 plus 8. No, this is 11. This is greater. So what should be decremented? When we are getting any greater number means it is greater than 10 means decrement j. Now turn comes. This is important. 3 and 6, it's 9. It is less than 10. Reason, the number may be more smaller. So let us go to little bigger number. So move I. So if the total is greater than 10, k, then decrement j. If the total is less than k, then increment I. Now check them. 4 plus 6, yes, there is one more pair. One more pair of element whose total is equal to 10. Then move next. Then as we got a pair, increment I also and decrement j also, now they have met at same place that are on single element. So pairing is not possible. So stop the procedure. So this is the procedure. Let me write on the code and show you. Now for performing this procedure, we need I in the beginning and j at the end. So, and we are not incrementing I every time. We are not decrementing j every time. So we cannot use for loop. For loop will always do I plus plus or j minus minus. It will perform always. We don't want always, right? So we cannot use for loop. We can use, but the code will not be easily readable. So to make it simple, I will use while loop. I assign 0 and a j at n minus 1. Yes, this is here and this is here, right? Now how long I should perform this process? While I is less than j. Once they become equal, stop. Then what I should do every time? Check if these two are added, then the result should be equal to k. Check if a of I plus a of j is equal to k. If it is equal, then print. So I'll print three values, that is first number and the second number and the total. So the first number and second number, suppose it as 9. So 1 and 9 will be printed. So if it is equal, this is first case. And when they are equal, I should increment I also, as well as I should decrement j, right? Then second case, if they are not equal, then this total may be greater or smaller. So I will write down else if a of I plus a of j, that is less than k. If it is less than k, if it is less means the number is smaller, so I should go to the bigger number. So I plus plus, I plus plus. Else means the number is greater, so I should decrement j, else j minus minus, right? See, if they are equal, do this. If it is less, then increment I. If it is greater, then decrement j. So this loop will continue as long as I is less than j, and it will stop once I is equal to j. So this is the procedure. Now analysis. What is the amount of time taken? It's very simple. Just we are going through all the elements, scanning them once, right? From the left side partial and from right side we are taking partial. Total number of elements that we are scanning is n. So the time is linear. It is linear. Linear means n. So I should say it's order of n or big O of n, whatever you call it as. I'm calling it as order of n. So it's order of n. It's linear. Now at last, one more thing. See, I have used while loop here. Is it possible that we can do it using for loop? Let us check. If I write for loop, then this is a condition. Okay, I'll just write it I is less than j, right? Then this is the initial part. So I should be equal to 0 and comma j should be equal to n minus 1, right? N minus 1. Then this is the condition I less than j. Then what about I plus plus j minus minus? I don't have to do it always. It is based on condition. So leave it blank. You can leave it blank. So now I don't need these statements, right? Because they have become initialization part and this is the condition. So this is how the for loop look like. Now for loop is not having one of the statement inside, that is whether increment or decrement, what is done here, it is not there. So that is missing, so it will confuse the reader what is happening here. So it's better using while loop, though you can use any one of the loop, or even you can use a do while loop also. So that's all in this video. Now let us look at a procedure for finding maximum as well as minimum element from a given list of elements. We have already seen how to find maximum element, and even we can write a procedure. Similarly, we can write a procedure for finding minimum. But the question here is we want to do it simultaneously in a single scan. So let us see how it is possible. I have a given array here with some elements, and the maximum element here is 10 and the minimum element is -1. So that's what I want. Now how to find max min? So I have taken minimum and maximum, two variables. So let us start the procedure. The very first thing what I'll do is the first element 5, I will assign it to both. So both minimum and maximum are 5 now. To scan the whole array, so for scanning I will take I starting from here. Now every time I will check. What I will check? Is it smaller than min? 8 is not less than 5. Okay. Then check, is it greater than max? Yes, it is greater than max. 8 is greater than max, so modify max to 8. Then go to next element. Now watch this step carefully. Check this element. Is it less than min? Yes, it is less than min, so modify this. Now when it is less than min, you don't have to check it with max, because your number which is smaller than minimum cannot be greater than max. So don't have to check with max, right? So you can save one condition like this. Then next element. Is it smaller than min? No. Then check, is it greater than max? Yes, it is greater than max. So next it is this one. Next, is it smaller than min? No. So check, is it greater than max? No. That is 6. It is neither minimum nor maximum, right? Next, go to the next element. 2. It is smaller than min? Yes. Modify it. The next element. 10. Is it smaller than min? No. Then check, is it greater than max? 10 is greater than 9. Yes. Modify it. Then 7. Is it less than min? No. Check here then. Is it greater than 10? No. Then go to the next element. Is it smaller than min? Yes. -1. Modify min to -1. Then next, this one. Is it smaller than min? No. Check, is it greater than max? No. So I have executed the procedure on the entire list, and we found the minimum as well as maximum element. So only the important thing that was to observe here is we can find it in a single scan, and if the number is not less than minimum, then we will check whether it is greater than maximum. If it is less than minimum, then we don't check with maximum element, right? So for this, I will write on a piece of code here, that is a loop that is scanning through a list of elements and finding maximum and minimum. So quickly, minimum is a of 0 and maximum is also a of 0. Then I need a for loop. That for loop will start from index 1 onwards, and the number of elements, as I have example of 10 elements, so I is less than n, that is 10, and I plus plus. So what I have to do every time, check if element a of I, if it is less than minimum, then modify min with a of I. If the element is not less, right, else, then check if the element is greater than max, if it is greater than max. Then change max to A of I. That's all. This is the procedure. Procedure is simple. Now you can see that this is in else part. If this is true, this is done. Otherwise, this is done. Now analysis. Analysis of this procedure. First thing, how much time it is taking? Time depends on the work done. So what is the work done? We are scanning through the list of elements. So how many elements are there? Some elements are there, n elements. So the time is linear. Yes, it is order of n. So first of all, the time is order of n. Now one more analysis I will do here. One more analysis. I want to know total how many comparisons are performed. Total how many comparisons are performed, right? Time already we have done it. So what was actually done when we set time is n? So in that time, what was done? The comparison and the assignment was done. Comparison and the assignment, right? Okay. So now I want to find out total how many comparisons are done. See, actually there are two comparisons. If this is true, then it will not go here. If it is false, then it will go here. So it means there are cases. Yes, there are cases. That is minimum time, maximum time. What is minimum time? Assume that always it is checking only this condition. It is not coming to this one. Always this is true. So when it will happen, if the list is in the descending order, like if you have the numbers like 10, 9, 8, 7, 2, and 1. So if you have a list in the decreasing order, then every time this condition will be true. 9 is smaller, right? 8 is smaller, 7 is smaller. Always this will be true. If the list is in descending order, then only this condition will be executed. So how many times the condition will be executed? As we are starting from 2 and stopping at n minus 1, that is n. So except one element. So total number of comparisons for this case, the number of comparisons will be n minus 1, right? One less. Then what about this one? See, if this is always false, then always it will enter into this one and check this condition. So in what situation it will happen that this is always false? So let us take the list. It is 1, 2, 3, 5, 8, 9, 10. Suppose the list is like this. Okay. If the list is going like this, that is an increasing order. So if I show arrow like this, this is a decreasing order. This is increasing order. See, this is minimum and maximum, right? Initially minimum and maximum. Every time I get an element greater than minimum, greater than minimum, greater than. So always it is greater than minimum, then always this condition will be checked. So how many conditions? 2 conditions will be checked each time. So total number of comparisons will be what? 2 into n minus 1, right? This condition will check, it fails, then this condition is checked. So 2 conditions will be checked for n minus 1 time. So the minimum time is n and the maximum time is also order of n. So in the best case, the number of comparisons are n minus 1, and in the worst case, that is maximum number of comparisons are these. So I'll show you something here. See, we have found out the best case and worst case. See, best case is list is in descending order, and the best case time is order of n, and if you are specific about the number of comparisons, then n minus 1. Then second thing, worst case. So case is different, time is different. Remember this. Case, define a case. What is a case? In which case the time will be more? The case is that the list is in increasing order, right? This is the case. And then what is the time? It is 2 into n minus 1. So it is order of n. This is also order of n. When we take the degree, it is order of n, and this is also order of n. But being specific, we want to know the comparison. So that is 2n minus 1. These many comparisons will be done. Alright. So time, we were saying order of n. Yes, in best case also, worst case also, it's order of n only. But the number of comparisons are different, right? So if you are concerned about this, then you can do the analysis. You can find how many comparisons or how much data movement is done. So that depends on you. So this type of analysis can also be done. So that's all, the best case and worst case. I am not showing the complete program. Even I will not write down the code, and I will not give you a demonstration on this one. This you have to do it by yourself. So it's a student exercise. Declare an array and write down this code by yourself and check it. And one time you take this decreasing array and one time increasing array, and debug it line by line and check how the comparisons are done, right? In this case, only this comparison will be executed, it will not enter here. Second case, it will execute both, right? So you can count them by yourself and you can see it by debugging it. So that's all in this video.